Uh, on behalf of EC Department at Government Polytechnic Ahmedabad, I would like to take great privilege and pleasure in extending a warm and heartfelt welcome to all our distinguished dignitaries, respected guests, faculty members, and enthusiastic participants to this FDP on Healthcare 5.0, integrating AI, TinyML, and robotics for real world impact. We are especially honored to have uh, our patron principal sir, Shri Bhaskar J. Iyer, and our convener, Professor Manish Charan sir, who is HOD of EC department, who is organizing this FDP. This online FDP is supported by AICT ATAL. It has been designated to bring together experts, educators, and researchers from across the country. Its aim is to explore how emerging technologies such as AI, tiny ML, and robotics are converging to create transformative solutions for the healthcare ecosystem. Healthcare 5.0 is not just a concept, but a movement that promises to make healthcare more personalized, accessible, and impactful. And it is our responsibility as academicians to understand these innovations and carry them forward into teaching and research. I'm confident that the sessions planned over the next few days will not only enhance our knowledge but also open new avenues for collaborative learning and future ready innovations. With this word, I once again extend my warm welcome to all of you, and I look forward to a meaningful and enriching journey through this program. It is now my honor to invite our convener for this FDP, Professor Manish Charil, who is HOD of EC Department, Government Polytechnic Ahmedabad, to address the inaugural function. Over to Manish Charil, sir.
Karna to survival a good chat. Good evening, all. Uh, respect our principal, sir, our patron, esteemed colleague, and dear participant. It gives me immense pleasure to welcome you all to this faculty development program on Healthcare 5.0, integrating AI, TinyML, and robotics for real world impact. This program is not just about the technology, but about shaping the future where healthcare and innovation come together to transform lives. AI, robotics, and TinyML are already making significant contribution from AI-assisted diagnosis in remote areas to robotic surgery in leading hospital to wearable devices powered by TinyML, bringing healthcare directly to people. For a country like India, these technology are not luxury but necessities, especially in reaching underserved communities. Such initiatives remind us that knowledge is most powerful when shared. The interaction and ideas exchange here will not only enrich us as educators but also empower the student and communities we serve. Faculty development program like this provide us an opportunity to rethink our roles as educators and prepare our students for an interdisciplinary futures. I thank our coordinators, faculty team, our principal, and AICT ATAL for their support in making the initiative possible. As we move forward, let us embrace these new technologies with responsibility and ethics, ensuring that innovation serves humanity inclusively. I encourage all participants to engage fully and carry forward insight that can create real impact in classrooms, research, and society. With this word, I warmly welcome you once again and wish this FFD great success. Thank you all.
Thank you very much, Professor Manish Charil. Thank you very much, Professor Manish Charil, for your insightful and motivating address. Your leadership in EC department continues to inspire for both faculty and students. We deeply appreciate your dedication to advancing cutting-edge knowledge and fostering collaborative environment through this ATAL FDP. Your vision and words today have set a positive and empowering tone for the entire event. Thank you, sir. It is now my honor to invite our patron for this faculty development program, Professor Bhaskar Iyer, Principal Government Polytechnic Ahmedabad, to address the gathering.
Good evening, everyone. Am I audible? I hope I'm audible. Today morning only, I was actually privileged to be invited by the same EC department for another FDP, which is actually going on in collaboration with NITTTR at RC Technical College in Ahmedabad. And the topic is very similar to what we are having here. There, the topic is on artificial intelligence, machine learning, and IoT. So I thank EC department of our college for having me here, and the most dynamic HOD of EC department for organizing two simultaneous trainings, one in physical mode and the other one in online mode just now, in the evening today. Thank you, Charil sir, for having me and for inviting me here. So a warm welcome to all of you. It is indeed an honor and privilege to address all of you today at the inauguration of this faculty development program on Healthcare 5.0, integrating artificial intelligence, tiny machine learning, and robotics. Basically, I am not a person of robotics or machine learning because that is not my cup of tea. I'm basically an architect and urban planner. But still, being an academician, I'm interested in all the streams of study. And being the principal of this college, I'm definitely interested in all these activities which all our departments are engaged in. So I extend my warm greetings to all our dignitaries here present with me. We are awaiting our director, sir, who is supposed to come and join me very soon at our college and address you. We are also waiting for Dr. Ragesh Kapadia, sir, who is our uh, training and placement officer at DT office, who is also supposed to join us for this program. So we are waiting for director sir and his team to join us here. In the meantime, for not wasting anybody's time, we have started this formal inauguration. So basically, I would like to start that in the beginning, I would like to say that we are in an era of transformation right now. Transformation in the sense that as academicians, it's very difficult for all of us to remain relevant in this era of transformation. Because what happens is the technology advances very fast. We as academicians, especially in the government setup, we are bound by certain restrictions. For example, let's say in our diploma, on behalf of our diploma side, if I speak, I can say that if EC department wants to change its syllabus after one cycle of 3 years with the GTU, it becomes quite tedious. It becomes very difficult. So we are not able to change the syllabus as often as required to be relevant in the modern times, in the modern transformative times. So that is our major restriction. but the technology is advancing very fast in the outside world. So we as academicians, we have to keep on updating ourselves as per the demand of the industry and as per the demand of the industry itself and the society also. Now, it becomes our duty to enable our students to become industry ready for the present industrial scenario as well as for the future scenario, which is going to be industry 4.0 and industry 4.5. So it becomes our responsibility. And for tutoring, for training our students for being ready for the future, it is our responsibility as academicians to enable ourselves to train our students, to teach our students about the new technology, about what all is happening in the industry today. So it's our duty to enable our students to become industry ready. Today only in the morning, I was reading in Economic Times that Meta AI, they are in the market in US. They are in the market in US. They are demanding for experts who are well versed with Hindi language because they want to create a chatbot which can communicate with the people in Hindi language. And Meta AI, they are ready to pay $55 per hour to this kind of an expert who can develop this chatbot which can communicate, which can converse in Hindi language. So that comes to around 5,000 rupees per hour and in US currency, in Indian currency. So that's a huge amount of money which they are willing to offer to such technocrats who are good with this language, who can develop, who can perform who can create a chatbot in Hindi. There was one more article in the news in the newspaper, which spoke about artificial intelligence being used for management of traffic on the highway. There was a article which stated that the highway stretch between Bangalore and Mysore that was monitored by AI cameras, and it was on an experimental basis, and this happened about I think 4 years back, and these AI cameras, they were very useful in controlling the speed limits and issuing challans for people who were overspeeding. So this functioned very well for the first 2-3 years. But then what happened is, as we all of us know, we are all using phones. If somebody is using an Android phone, Samsung phone, there are updates available in our phones very often. And say after using your phone for 2 or 3 years, the phone becomes more or less obsolete because we have to go for new technology. You have to go for a new phone which can absorb new technology and new updates. Similarly, the same happened with the AI cameras on this stretch of highway between Bangalore and Mysore. The cameras had to be updated, so the entire set of cameras had to be replaced. This is something. This is an example which I am sharing with you. So, along with updates, along with the improvement in technology, there comes a kind of a hidden, environmental concern where these cameras, all these old cameras, they had to be removed and they were junked because they could not be used anymore because they could not adapt to the new technology or the updates in the technology. So as and when we get new updates, new upgradations or improvement in software, in robotics or AI or whatever platform, we end up with more and more electronics junk. So we also have to address this issue of handling electronics junk in the future. There's something which might be a concern in future, which we need to start thinking about addressing in future. Just like what is going to happen in e-vehicles. Right now, it's era of e-vehicles. Most of the people are going for e-vehicles nowadays. Lithium-ion batteries. If some mechanical engineer is there, he will agree with me that lithium-ion batteries, they have a certain lifespan. So after this lifespan, these batteries will conk off, and we may have to go for some new technology. So again, we'll be ending up with a lot of junk, battery junk. So, so these are the hidden dangers with the use of more and more upgradations and more um, so use of software or updated technology. At the same time, we adopt all this technology for improving our lives. So, and as academicians, I repeat that it is our duty to gain knowledge from all these faculty development programs and share it with our students so that our next generation is ready to grow, to adapt to change, and be continuous learners or lifelong learners in their entire lifetime. So thank you again, EC department, for having me here and allowing me to speak to all address all of you. Thank you once more. Thank you. And I wish all of you to have a great time on this with this online FDP.
Thank you very much, Professor Bhaskar J. Iyer, for your inspiring and motivating address. Your unwavering support and visionary leadership continue to guide Government Polytechnic Ahmedabad towards academic excellence and innovation. We are deeply grateful for your encouragement in organizing this ATAL faculty development program and for taking the time to join us. Your words truly set an optimistic and empowering tone for our program. Thank you, sir. We are deeply thankful to our patron, Professor Bhaskar J. Iyer, and our HOD, Professor Manish Charel, for their constant guidance and encouragement. A sincere word of appreciation goes to all participants for joining this program with such enthusiasm. I also take this opportunity to acknowledge the dedicated efforts of my fellow coordinator, Dhaval Modi sir, Satish Kataria sir, and my team members, Apurva sir and Jiten sir, uh, who has worked very hard to make this event possible. With these words of gratitude, I once again thank everyone and formally announce the inauguration of this faculty development program. We look forward to an enlightening and enriching week of learning together. Our next session will be a technical session, and we request everyone to keep joined. Please be joined, and the sir will join us within 5 minutes. Sir has also. Okay, we have an update that our first speaker of today, the first session, which is conducting by Mr. Rajesh Bose, has already joined. Good evening again, everyone. It is my distinct honor to introduce our esteemed speaker for today, Mr. Rajesh Bose, Director of Programs and Partnership at Cure.ai. With a strong commitment to transforming healthcare through artificial intelligence, Mr. Rajesh has been instrumental in driving Cure.ai's global initiatives and partnership. He has been recently awarded the Next Gen Leader Award, his third consecutive recognition in the field of AI in the healthcare. Under his leadership, Cure.ai has deployed AI-powered radiology solutions across more than 90 countries, impacting millions of lives. The company's AI models assist in the rapid and accurate detection of critical conditions, including lung diseases, brain abnormalities, and tuberculosis, helping healthcare providers deliver timely and effective care. Today, he will share his insight on AI in healthcare, current and future prospects, exploring how AI is reshaping diagnosis, patient care, and operational efficiency. and what exciting developments lie ahead for them. I would like to request Mr. Rajesh Bose to take over the session. Mr. Rajesh Bose. Hello, Rajesh sir. Sir, am I audible? Have you already joined? Let us wait for 5 to 10 minutes as uh, the speaker will respond in few times.
Hey, hi, ma'am.
Sir. Hello,
Hi.
sir. Welcome, sir.
Okay, great. So,
Sir,
is
we can start
yeah,
now.
okay.
Yes.
Has this been session going on since morning or what? Or is it like we start in the evening?
No, we have just started this session. You
Okay,
are our first
perfect.
speaker. Yes.
Okay, perfect, perfect. Okay, that is good. Okay, hi everyone. It's very, I mean, first time I'm actually, usually in corporate we have a smaller crowd when we do for the things. Otherwise, we go for a normal non-virtual events. But yeah, but it's very happy to see a lot of teachers and a lot of people who are building the generations. I'm very happy to be here. So before starting, I'll give a quick introduction and quick context. What are we talking and what am I doing and everything. So my name is Rijesh Bose. I work as director of programs and partnerships in a company called Cure.ai. So we started in Mumbai in 2016, and it's been 10 years, almost 10 years. I mean, we've been working. So we've been in the domain before even AI becomes a buzzword. Maybe after ChatGPT 2020, 22 onwards, I mean, everyone uses AI. AI has becomes everyone's daily tool, but we've been working with AI before that itself. And what we started in Mumbai, then we have an office in Bangalore as well, and also we expanded across the globe. Currently, we work in 100 plus countries through our different AI products. So I look at all the operations in all the geographies, including India, Middle East, Asia, Turkey, and all. So that is the geography we operate. I mean, we also work in US and other countries, which I don't look at the operations. We have a team, centralized team currently there. So what in today's session, what we're going to do is I'm trying to keep it very interactive and trying to share what my understanding and experience of AI in healthcare, so that you can also get your context built. I mean, because since it is a very diverse set of audience, some of maybe are you may be well aware of AI, so I don't need to even explain things. Some of you may be reading things recently, so you can, I mean, may get benefit. But since it is a very wider pool of people, I kept it very simple and very not very technical jargons. It's very simple, very understandable stuff. But if there is anything in detail or anything in content wise to go deeper, please raise the hands and ask the questions, or like maybe you can even connect after later. Anything works. So with this context, I will get started. Once again, thank you, ma'am, and thank you the team for having me here. I hope my screen is visible for everyone. And yeah. So yes, someone has raised the hand. Okay. Okay. I hope I can I start, or are there any questions before starting?
Yes, sir. Yes, sir. We can start, and your screen is visible, sir.
Okay, perfect. So if
And
there
I
is any
think,
questions, we'll take at the end, right? That way.
yes, we'll take it at the end.
Okay, perfect. Okay, so first of all, I mean, I'll start with why AI matters in healthcare, right? And why AI need in healthcare. So think of a scenario, right? Maybe 15, 20 years back, or not even 15, like maybe 5, 10 year back, the hospitals were, all the healthcare sector was very different, right? I mean, we go to the hospitals, we try to get a treatment, and we do things, and we wait for our things. But something happened during COVID, or something as a community we realized during COVID is data is everything. So when we have data, we can predict. So we can, we can actually move from a data driven healthcare. And data driven healthcare is the key to everything. Even if you think, so we in epidemiology, we say, right? I mean, we know, think of cholera as a case, right? So I am a ward member, and so if I'm looking at all the where is the cholera cases coming, so if I observe the data, I can understand the cholera cases are more from a separate ward, specific ward of my thing, and so more cases are coming in this area. So there is a like need of data, right? So we understand when we analyze the data, so we understand there is a epidemic infection in that region, and then we try to predict. So then we see every year data. So every year the same place is affecting by cholera in June, July months. So then we go dive deep into the data, and then we understand this pattern, and then we accordingly do things. So that is where data becomes. I'm just quoting an example. So what if we have this data, we train some model to this data so that it predicts before things, right? So in an hospital or in a public health settings, everywhere. So if the data is built and data can predict things, so it would be making healthcare faster, easier, more accessible, more affordable, and it can be scalable across the globe quickly. So that is why the healthcare has shifted. There has been a paradigm shift last 5-10 years. So now everywhere data is important and data is available also, and technology is also available. So there is no point in not using AI in healthcare. So with that thing, I also quote one more example. So there is a product in my company, we use it called QXR. So what that product does is, so we have millions of data of tuberculosis. So we have trained the model how a tuber X-ray with a tuberculosis looks like. For example, the lesions, which part, what is the consolidation, what is the opacity, how the X-ray of a TB patient looks like. So we trained the model, we trained the algorithm in a way that so now the algorithm can know when it see an X-ray of TB patient. So that means, so normal taking chest X-ray, someone going to take a chest X-ray in a hospital, so they understand. I mean, the AI quickly, fatafat AI catches, okay, this patient has a TB. So then AI flags it for the further testing. So that means there's a lot of manpower, lot of human resources. Otherwise, usually conventionally, how it happens, some ASHA worker or some health worker goes to this people, try to get people to the hospital, and after saying that, the doctor has to look into it. Then after that, maybe sputum examination has to do it. So a lot of operational processes has to happen to confirm a patient. So with AI, something that can be detected from an image, it can be done quickly. So that is where that is why AI matters. I mean, this is just one example I'm quoting. And then the another thing from a teaching angle for you, you are handling students with this, like, who may be better than you, like they are also, because they grow when the technology is bloomed up. So not like us, right? We grew along with the technology. When we were students or we were kids, we didn't had any of these things, whatever we are using or whatever our students is using. But along with it, we were learning it when it come and when it became a need. But the current generation or the students whom we are handling, or the people who are growing right now, so they have a very different access to things. They know it. I mean, that's part of their life. They know it since their birth, or since their, like, early teenage. So that means they are definitely their access to this, and things they know would be, sometimes we cannot imagine the deeper they understand things. So to get and to communicate to a crowd like that, and a tech enabled crowd, we also need to equip ourselves in understanding. So especially in healthcare, that is something missing also. Wherever I speak with healthcare medical colleges, I speak to them, right? We need AI as a subject also coming to the medical syllabuses now coming going it. Okay, now some of this maybe, you guys may be knowing things, but I'm just trying to going with the key components of things, so that you can understand and make it more clear that what we are referring to, what we are understanding. So these key concepts are very important to understand. What is AI, and how, one second, okay, how AI can be read, and all those things. So for that, like, I'm just trying to explain you few things, so that it gives you, like, it gives you an understanding on what we are talking about. And when we hear this word, you don't need to confuse. So the basic thing is machine learning, right? We hear this word everywhere. Machine learning is the foundation of AI. That is something we everyone uses it every time. But what exactly it is something I mentioned, right? Machine learning is an branch of AI where we are building algorithms are basically programs. I mean, you all of you may be knowing. So of all programs, like these algorithms can learn patterns from the data. For example, I said the cholera thing, you can see, right? So this they understand the data, they understand the pattern of this data coming, and then with this pattern, so it can predict, and then this model is built, and without being programming every time, without that extra programming, machine has learned to do this program. So then that means we don't need to code every time. Once the machine learning algorithm is built, that can pick up things when it is deployed in a real-time settings. So that is how it becomes it is the core foundation of AI. Basically, it is a branch of AI where it can learn patterns, to from data and understand and predict things. So this is basically, this is like, we don't need to code every word every time. So that is why ML stands as the key foundation of AI in current era. And every all the AI programs are like basically in machine learning, a byproduct of a machine learning. Now another thing that we also hear is like, something like, natural language programming is also something that we hear. So that is also something we need to understand, because that is where it's a field of AI where human language. For example, ChatGPT does, right? I can speak like any way in ChatGPT or to any other AI tool, right? So it understand and interpret the human language, the way we communicate. So that it is like, it is not even, we are not communicating. I mean, we don't need to even speak like we are speaking to a robot or a machine. The whatever way we speak, all the chatbots, all this, chatbots of the Zomatos and all work on NLP, so that it have text and speech recognition, and it also runs on all the languages, and even emotional angle, now building on the natural language processing. Even if you're sad and you speak to GPT, it understands you are sad. So that is the way where the NLP is progressing. So it basically, in short, it allows the machine to read, listen, and talk like us, talk like human beings. So that is what NLP does. So I just want you both to be clear on all of you to be clear on this concept. So because, so that when we talk, then we understand, right, where we what are we speaking about and what are we understanding. So now another thing is like, where is currently AI, right? In healthcare, AI is like, it's not as we think. Sometimes we think that all the healthcare is like, fully artificial intelligence has taken AI. No, still people prefer going to a clinic, being touched, being talk to their doctor, have a good nice conversation, and after that, going to their pharmacy, buying medicine. So though there is technology has boomed a lot, but still the perception and the need of people is very different. They still want that, that physical care, and that feel of a hospital, that smell of a hospital. Everything is much thing. I mean, it is not, it's a behavioral thing, right? You won't change it over the time, over the night. So let it happen over the, like, let it take the time, let the healthcare transition happens over the course of time. But right now there are certain areas where AI is very clearly impacting, and already the impact has started. So that is diagnostics mainly. Why diagnostics? Because diagnostics, like if you go back to the concepts you mentioned, the concept of machine learning and NLPs and the LLM, large language model, everything can be implemented very easily. So radiology, pathology, dermatology, diagnosis from in skin, right? Some of the skin lesions. So all those things, all that is where AI has most impacting currently. And again, like take an example of radiology, like why it is easier or why it is impacting more. So think of a scenario where, like, I trained an AI to say that, you are seeing a dog. So AI can see a dog. So AI say this is a dog. And then I trained the model. So what is white, what is black, what is blue. So now AI can say that which is a dog, which color it is. So AI will say that this is a black color dog. So now think of an X-ray, or think of something else. Think of any image, right? An image of a CT image or an MRI image. So now we get a chance to get all these images to train a model. And another thing very crucial here is the foundational image is same. For example, the structure of us as a human being, right? The anatomical structure is globally, universally, it is same. So like maybe like very few exceptions, but globally 99.9% everyone possesses same anatomical structure. For example, everyone's ribs look same, number of bones, number of structure, the skull, everything is same. So that gives that easiness. So now everyone who's having a lung cancer, so that the malignancy growth in their X-ray or CT looks same. So when this caveat is there, so what in diagnostics we will see. So anywhere, even if it is in Africa, even if it is in America, even if it is in India, Ahmedabad, anywhere, a lung cancer in X-rays can be found as nodules. We call it pulmonary nodules, IPN nodules, interpulmonary nodules. So any nodules, so right, so this malignant nodules are looks alike. So now with this concept, so we can train an AI program to understand what is a nodule and how classification of nodules, segmentation of nodule, then go deeper, right? Give them different type of nodules, teach everything about nodule, and what is malignant nodule, what is benign nodule, how a cancerous nodule is detected. So now, like, get millions of data, get the ground truth of this data. Ground truth means actual, truth of this data. And with annotators and with doctors and with clinical expert, we make this algorithm. We build the algorithm, which can now, once the algorithm is built, now it can understand and it can read the nodule. So that is why diagnostics, it is impacting, because it is a very advanced structure, where things can be easily implemented, and there is like already a lot of machines and the analyzers are already used. So it is also easy to integrate into these machines. For example, there is a Fujifilm as an X-ray console. So someone else have an AI software. So this AI product can be embedded to the Fujifilm X-ray console. So that hardware software marriage or the matching is also easy. So that is why it is mostly impacting in diagnostics. Same with pathology. Same with pathology is like, many of you may be knowing, right? When I see, right, how a cancer cells looks like. So then that's like the histopathology of this, anything, not even cancer, anything. For example, a malaria, how's a malarial parasite looks in a microscope. So it's all same. It's all universal. So we can train the model. So that makes AI to quickly read these things. And this will help to do a lot of reduce a lot of human repetitive human task, right? For example, a doctor looking at 1,000 x-rays, it's tiring, and he can use that time to read CTs or MRIs or maybe some other things which is more high on paycheck, high on things, and high needs a more supervision. So something small, something repetitive, something mundane can be given to AI. So that is why in healthcare AI is booming, and diagnostics is the primary example of that. Now coming to another thing is risk scoring and disease progression and prediction. That is predictive analysis. For example, all this, wearable devices and all which we have seen, right? So they all part of it. So anything, right? Anything you want to predict, AI can easily predict. Why? Because you know there is a pattern of progression. For example, someone who is becoming obese or someone who is becoming a diabetic, right? So there would be time where he was a normal person. Then we see that his sugar is going to borderline. Then his diet intake is changing, so his sugar is going to, and he has a genetic factors. His mother or father is diabetic. So when AI has this data, when AI is seeing this pattern, it can predict. So for example, so AI can tell to you, hey, if this is the pattern you are going, by the 45, you will be diabetic. So basically, so the person, predictive analysis is very much currently happening in AI, and everyone does it. And it is basically a doctor telling, but with more, but not, basically it is same as of a doctor telling, but here AI has access to more data and more, like, it tells on the foundational principles, right? It needs genetic data, it needs progressive data, it needs the kind of diet, whatever data needed for a pattern. For example, diabetics needed a set of data, anything else. So all this data has been collected, and the disease progression or the metabolic progression has been counted and communicating back to the patient or communicating back to the user. That is what happening in predictive analysis. So diagnostics and predictive analysis are very sorted few areas of AI, and there are like millions of money coming into it. I mean, I believe you also wants to know that, right? I mean, globally there are like startups, there are investors, and diagnostic and predictive analysis is two sectors of AI. But there's a lot of big VCs, big venture capitals are investing, and there's a lot of changes and a lot of innovations happening in this thing, and a lot of R&D is also happening. Now, another area of AI is operational efficiency. So this is more from a very hospital standpoint, right? It is not from not from an not from more of an R&D standpoint, but think of a hospital where there is a lot of operations are running through on a daily basis. So something like this happens. So everyone, right? I mean, anyone who can increase the operational efficiency. What will happen when operational efficiency increases? Definitely, it will lead to increase of revenue. So again, I'll take an example for the easiness of understanding. I'll take the example of radiology itself, because that's a domain which I worked most. So for example, 1,000 X-rays are done in a radiology room, and a doctor, like doctors looks into all these X-rays, different doctors, different looks. So now 1,000 X-rays, instead of everyone coming and looking into X-rays, what if AI is looking into this 1,000? One, the time is managed. So AI can read all these X-rays in 10 minutes or 15 minutes or 30 minutes. So that means all the, so all the doctors get more time. And there are, like, if it is a medical college, there are students to be learned, all those things. So they can invest their time to more valuable and more, where they need. So once this will happen, what will happen? Think of a private hospital. So if it's a private hospital, they are paid. I mean, consultant radiologists are paid for hours. So for example, and these guys are like, now you are paying, you don't need a lot of time from them. So, but what will happen is, so the hospitals can increase their revenue. Private hospitals can increase their revenue. Public hospitals can, you optimize their resources. So all these things can happen. So that is why operational efficiency, AI can add a lot of value in operational efficiency currently, and which is already happening. And that is another sector of AI where there we do a lot of R&D is currently happening. That is in operational efficiency, and there are other aspects also for the operational efficiency. So now I'll pause here. So I hope everyone you are able to follow the session. If there is anything, I mean, I'm just pausing the session for a minute, just see any comments or anything in the chats. Okay. So we'll continue, ma'am. So I see people raise their hands. Are they, is this for
Yes, sir.
questions?
Yes, sir. We can continue. I
Okay.
think we can ask who has raised the hands.
Okay. If there are any questions, should I
Sita,
take the questions now?
if anyone from the participants want to ask anything, as I can see that 4 participants has already raised the hands. Miss Madhvi, Saurav Verma, Parita Patel, and Sita Bhargave. Anyone wants to ask anything? We can take queries. I think, sir,
Yeah.
we can
No, I'm saying,
continue this. Yes, yes.
okay. I mean, if needed, we can take questions now, because otherwise I just want people to be on speed, right? I mean, because I am someone who speaks very fast, so I just want to make sure we are, So okay, if there are no questions, then I will continue.
Yes, sir. We can continue the session. We'll take the
Okay.
questions at the end.
Okay. So we were talking about public health. What is public health, right? I mean, this is another area of where there is a lot of AI. So public health is basically anything, right? Any government, like government of Gujarat doing a national TB program, that's public health. And anything, any screening program, or government of any government or anyone, right? I mean, the idea of public health is anything that is intended to do for a public good. So that's all parts of the public health. So public health is another domain, like, governments, like, across the globe. So government of Kenya, Tanzania, India, everyone is using AI in different. And mostly there are certain diseases like tuberculosis, or like, where, because there is lot of screening is needed. So public health uses AI mostly for screening programs currently. So and also the financing of this is not always by the country. Sometimes, they all get philanthropic aid, for example, Bill and Melinda Gates Foundation, USAID. There's a lot of people, right? And sometimes, the rich governments also buy from their own. So all these things, right? Screening of breast cancer, you have seen. So there is a company called Niramai. They have a AI tool to screen breast cancer, and we have AI tool for lung cancer. So there are like all the screening, because why screening? It's from a health economic angle, right? For example, if I find someone with a lung cancer today, that is, he's a stage 1, or like, stage 1A or 1B. So that means, one, he will survive, and it can be treated. And two, his quality of life will increase after the things. And his economic angle, right? He's what he's contributing to economy, what he's contributing to state, what he's contributing to his family and his everything. So that everything would level up. So from an health economic angle, there is a lot of benefits for a state or a country or a government when they use AI programs in these things. So we call it HEOR, health economic outcome researches everyone is doing, and there's a lot of epidemiological and economic insights we have seen. For example, I'll give one more very understandable example. So there is a tuberculosis test called which is a confirmation standard confirmation test for tuberculosis, and that cost around good amount. I don't know exact 5K 6K something it cost, but an X-ray costs 250 rupees. So for example, in if AI is screened in X-rays, we don't need to do confirmatory test for everyone. Only the one AI flagged as high risk or positive only need to do confirmatory test. So that means 80. So that cartridge, right? I mean, it is called TrueNAT, CBNAT. That is this machine, TrueNAT and CBNAT machines. So this machines, one cartridge costs 3.5 to 4,000. So government or the corporations or whoever is doing, they have to procure it for every test. So now when you do an X-ray, so out of 1,000 X-rays, only maybe 200 or 100 need that confirmatory test because AI do the first level of screening. So then instead of 20 lakhs or two, which the health system has to spend, now it has come to 2 lakhs because only 10% you need to spend. So that is how AI is adding value to a public good, like public insight for the governments and for those things. So that is why AI's use case in public health is also needs to be understood and needs to be researched. And you can read about case studies which is available in the public domains. This is more or less which I said. I'm not repeating again. Virtual health system is chatbots and triage system, which is also an AI use. This is not a majority use case. What I meant is majority use case because this is a part of AI. Like if I am building a tool, I will also build a virtual health assistant. And there is it is it is a use case which is already across it's not only an healthcare thing. Everyone, like for customer care complaints, an insurance company can use an virtual health assistant to collect queries. So a lot of things. It's not something very confined to healthcare. Everywhere it is there. Basically, chatbots and triage systems are the part of this thing. So that is what it is called, virtual health assistants. Now coming to now this is again I want to just to understand, right? I mean, why this is this is a case study of radiology. For example, if you are teaching something AI to students, or if you want to have an engaging discussion in your school, your classes or your colleges, so this is something that you can do. You can always think of a case study, how radiology as a domain, right, has been impacted. So radiologist has been impacted. What are the stances where we are in case of radiology? So this is a very interesting case study if any of you want to go through it. For example, I already mentioned tuberculosis, lung cancers, lot of things are currently which we are handled in this thing. Another thing also we need to understand is the who reads an X-ray and decide things. It's basically a radiologist. How many radiologists we have? How many MD radiology seats we have in this across the globe, across the country? So that is also one thing we are solving, right? So instead of we are also AI is also solving the gap of specialists. So that is also something you need to understand, and students can read more about it. So there are few radiologists, but their demand is huge. So AI is fitting this gap. So AI is making it more accessible and more affordable and more available to the wider public. So this affordability, accessibility, and availability are the foundation of a public health or any program. So AI can help for radiology in that. So that is I just took it as an example. So you guys can, I mean, maybe at a later as an exercise, your colleges you can do it as a case study. So also think of a low resource setting, right? Take some village in Gujarat or any part of this. There is no radiologist available at all. Though you to get a first radiologist, you have to go 30 or 50 kilometers. So that cases, if they have a computer and a decent internet, we can deploy AI, and AI can read the X-rays and read the people and do the help. So it can do the detection fastly, and it can also scalable across the settings in low resource. Even a primary health center setup, very basics, we can do things. So that is why these use cases are important. So radiology is a very sorted use case. There's a lot of companies in US, in India, and in Europe. There's a lot of companies who are working in it. And so this is an interesting case study. If anyone wants to read more about it, I would suggest you to, your students or something to do with that. And it's a very interesting domain. Now, again, I mean, this is again very easy to understand things. There is nothing more or less we have already spoken, but again, I'll quickly go through it because one is faster and accurate diagnosis because AI is trained, and it improves its way of training into it. So it can diagnose things, detect things very fast, very quickly, and very accurately. So accuracy is a very conflicting topics. So we say sensitivity and specificity. When you can, for screening programs, you can increase the sensitivity with a low specificity, but for a confirmatory test, you can increase the specificity, reduce the sensitivity. So this threshold can be managed and adjusted by the algorithms. So we do it according to the context of the program or context of the use case or context of the user. Then another thing is reduced workload for clinicians. So any radiologist who's looking at 1,000 X-rays, now with AI, he can look only 300 X-rays. So he get more time. His workload is reduced. His burnout is reduced. So all those things. So that is another advantage, and which is a very direct use case, direct advantage, and better patient outcome. So our patient outcome, the classic example is lung cancer or breast cancer, anything, right? You detect it in stage 1. That means you get your life back. So if you are detecting any lung cancer in 4th stage, otherwise, to usually lung cancers or any cancer, right, it becomes very symptomatic and very severe in the stage 4, and this progress goes very fast. And by the time this growth is very huge, I mean, it's very difficult to reverse things. So that is why AI can always help in a better patient outcome if it is, used efficiently and optimally. Then another thing is scalability in resource limited area. So for example, WHO has a report in 2020 WHO report. WHO says AI can be used in settings where there is no radiologist for TB screening. So that is the level where right now AI is adopted in the international areas and international agencies. So for example, we are a huge society in taking the world. There is a clear gap of resources. Cities, even take Gujarat, right? Ahmedabad has a better access to everything. Think of someone who lives 500 kilometers away from Ahmedabad. So anywhere, like any Mumbai, I mean, take Maharashtra. I lived in Maharashtra. I lived in Mumbai, and I travel 1 hour. Like I get to, like the Virar Vasai cross, then I reach to Dahanu and all. I mean, it's the Vikramgarh, Palghar district starts. The gap, the difference in the infrastructure, difference access to resources, everything changes when you travel 1 hour in India. So that is what AI can, bridge those gaps. That scalability in resource limited areas can be done by AI. Then cost saving and the economic angle we already discussed. Then yeah, now come to the key areas, right? Why it is important? What are the issues? What are the challenges? What you need to understand? Things are not always green, right? There are other things which we need to understand. And what are they? Right? They are basically we need to understand. First and foremost is data and data privacy and security. So any AI model, the foundation of them is their data. So if I'm deploying a solution in a hospital in Ahmedabad or anywhere, any medical college, that means my AI tool is accessing the data of this hospital and or this public. So now, what are the data privacy? Like whose data is this? It is public's data. It is human beings' data. So, like, can this data go to go to some private company or some agency? These are the questions, right? So they can use this data, misuse this data, sell this data, anything can be done. So to challenge or to concern to protect the data privacy, there are certain rules, regulations, and regulatory frameworks. It starts from the FDA, which you must be knowing. FDA is a US approved approval agencies for anything, right? All the drugs, all the technologies has to be FDA approved to run in US, and there is CE approval for Europe. So anything has to be CE certified to run in the EU countries, European Union countries. India, it is right now managed by CDSCO, Central for Drug and I think drug and cosmetics. Yeah, CDSCO is still doing. So CDSCO gives the class 2 certifications for any software do that. So making sure that it is regulated to work in the country. So data privacy is a major concern. So any company, how they need to solve is, one is to get rid of PHIs. So even if I am taking a data from hospitals, I shouldn't take any PHIs, any protected health information, any identifiable information, name, age, sex, what is there, all those things has to be anonymized or anonymized and to come to the cloud or can come to the processing. So that is a very foundational thing of any AI tool. So real world settings, if we are taking data, that has to be anonymized. There has to be technologies, there has to be checks to anonymize that data. No protected health information goes to any AI company. That is what fundamentally this regulatory frameworks looks into it. So that is what I talk about. I mean, there are regulatory certifications for also for that. Any country you work, if I want to launch a product in Vietnam or Taiwan, I cannot go with Indian regulatory, right? The product has to be freezed in these things. And in India now, DPPI is also coming. That Digital Privacy Protection Act, which is also coming. It will also has more closures. So then companies will has to, according to, adhere to their terms and their uses to according to it. And another thing is bias in AI model. Representation issue is a major thing. So, for example, anything you build, right? I mean, usually classically what happens are most of these AI models are built in Western world, US or Europe, and they have a clear I mean, the data they train is mostly their population. So that is one bias it comes. The another thing is from India, we are building a solution. We mostly 70% of our data is built on Indian population. So sometimes, some scenarios, the bias is a thing, right? So for example, the way it works well, it may not be working in a different population. So though we say anatomically everyone is same, but physiological and environmental and other external factors are different according to the geographies. So those biases has to be surpassed, has to be trained. So AI shouldn't have that bias in this training models, is what I'm trying to say. So any AI model, they should have a uniform distribution of their training models. Then regulatory approvals we spoke. That is basically any company or any solution or any software to work in this thing. It has to go through all the regulatory frameworks, and FDAs and CEs are much needed if it has to go to the global market. And also we also talk about the HIPAA guidelines and the has to be complied. So all those guidelines are part of it. That is a core and part and parcel of any AI company or any AI solution. That is a challenge also, but it is not. It is a way to work it. It's no, we cannot say always it is a challenge, because that is why in healthcare these regulations are very strict. That is why you see lesser companies, comparing to other domains to come in healthcare and working in it. Now, going to integration to clinical workflows. So I'll take a minute here. What is clinical workflow, right? Every hospital or every doctor, they have already an existing workflow. For example, patient comes, token is taken, given the token, patient goes to the doctor's room. From there, they go to the pharmacy, they go to the lab, and they get their stuff done. So this is what existing workflow. So now when we introduce AI to an existing workflow, there are high chances, right? It gets like very confused. It increases the workload. So that adaptability, that resistance to begin, right? That to what is the word, to merge it with fully, to without disrupting the existing workflow. Introduction of these technologies and these activities is a challenge. So it's an operational challenge. So we won't solve it over the night. We have to train the doctors, we have to train the healthcare staff, we have to be there, we have to start them using. Maybe 20 years back no hospital used EMR or EHR, but now everyone uses, because they made sure that change is a part of their thing, and they had regulations, they made train the people, they made sure that is a mandatory step. So similarly, AI will be in soon will be like that. That is another thing which we need to do, and another part of which we need to understand is this thing, right? The acceptance. Again, India is a very dicey country. Not everyone wants to accept everything being given. So there is an acceptance and adoption biases which is currently happening. Some doctors who has a more of a who likes technology, who wants to try out things, may adopt, but someone who are like just want very rigid, who do not want to things. These are behavioral things, but it is a fact. It is a fact across the globe. It's not only with India or anywhere. We have to get their trust to be part of their workflows. So getting that trust on the product is very important. Companies are doing researches, empirical evidences are being created, but again, right? So to get that trust and to get accepted, adopted, and used as a challenge in clinical health settings, and companies and everyone is working, and this is a very fundamental challenge any AI product or any software which is facing. Now, again, what are the ethical concerns, right? There are certain ethical concerns which we need to understand. One is patient consent, right? So this is a tricky question. So there are certain countries where we say any patient who go through any AI test or anything, they had to give a patient consent. And how transparent these consents are, that is another question. For example, if you use Google or anything, you see their consent forms in a very small fonts, like in a very detailed. They'll make sure that we are not reading. So that way, anything, right? So all these consent forms and all these things are built in a very dicey way. And currently, there are no regulations in globally, which is putting everything into a framework. So in India, there's no need of taking consents. I mean, if you know, so now, like, any AI company can do it and do it with the hospital. So now once the coming of DPPI Act, it will come, right? And the ethical angle is something that we all need to discuss. But if the product is giving the benefit to the patient, definitely it can be used, but not at the cost of his or her data. So this ethical angle is something everyone has to, think through, and the policy makers and the government has to come through it. My take on this is patient should know when AI is being used. Patient has the right. I mean, in as per the Indian, as per the right of me as a patient, I should be knowing if my tests are run by an AI. So that sort of consent is very important. Then another thing is equitifying things, right? AI shouldn't benefit only rich hospitals or this thing. It should be everywhere. It should be there to. It should be accessible to everyone. So that is also another ethical concerns. Right now, rich has access, or people living in urban areas have access to everything. That should slowly. I'm hoping it will slowly change, but that's also another point which we need to do. Another thing which we need to be clear here is ethics are as important as technology. However important is the technology is built, how whatever the engineers say, whatever the builders say, doesn't matter. Ethics and the patient rights and the those angle, right? Ethical aspects is as important as your technology. It is as important as your thing. So for anyone, any company, when Google build it or Bill Gates builds it, whoever builds it, but ethics and the patient rights are foundation. That is where anything has to be built on that trust. Now, quickly, just being sensitive of time, we'll quickly flag through the future prospects of AI. I mean, AI has been doing a lot in healthcare, but there are I'll go it very fast, right? I mean, another thing is personalized medicine is something which is happening very soon. So basically, genomics to tailor cancer treatment. For they say, right, our genes. So basically when a baby is born, so you can get the stem cells, understand the gene, and get a thorough analysis of these genes with AI, and then personalized medicine, right? Not the I don't need to take the same medicine or same dose of this thing. So it would be for my gene, it would be better to these things, something I take a different combination or a different dose. So that is something which is going to happen soon. So personalized medicines, there's a lot of R&D happening, a lot of R&D happening in everywhere. Then another thing is, again, tailored treatments, which I say personalized medicine is like this is a combined point. Then another thing is AI driven drug discoveries, right? So we are doing AI is fundamentally reducing the R&D. Pharma companies are now, after coming AI, pharma companies are building a lot of money also. They are they are doing their researches faster, R&D faster, all the analysis faster. So AI is helping all this, clinical trials, the data analysis, and all the things are very faster. So AI is very well used in the clinical trials, and soon it will be a regulate. It's not currently regulatory approved. Soon it will be part of the regulatory framework. So you will see a lot of AI uses in the drug discovery. Then another thing is smart hospitals. In US and all, they have tried it, but it's not a successful model yet because it's fully managed by AI and the robotics. So that is also something that is we will see soon, right? Where AI can support everything, right? From the registration, no people, maybe your doctor is also an AI supported thing, or your registration, everything can be done. Everything technically can be done. Now healthcare is, as I said, ethics and the regulatory side of healthcare is very strict. So still now things are moving very slowly on that area. Then mental health again, right? AI is already doing. Even I'm sure that many of us, you ask ChatGPT or the AI tools of our mental health concerns. But slowly, it would be more regulated. So therapeutics, counseling, all those things will also have more of AI tools coming on that front. Because mental health, sometimes all people need is to when they need to speak to someone, they need someone to guide. But currently counselors and psychologists are doing. There is in future AI could do it, but again the regulatory and the ethical aspects of it is something that we are still discussing, right? So everything will come with a check, everything will come with a because the full potential of AI will be never used in healthcare because healthcare is very delicate unless any other sector. Okay, so just I mean, since it is a digital health era and you're talking to a lot of students, I mean, I would encourage, right, whatever they're studying computer science, mechanical engineering, whatever it is, tell all of them to get that, get into the habit of understanding the use cases. Use case is the word, right, to use. And it need not to be in healthcare. They can explore it in the other telecom industries, petroleum industries, anywhere, how AI is doing it. I mean, now coding, I mean, 5 years back, someone who knows to code, who does a brilliant coding, I mean, they are a brilliant engineer. Now it has changed. Now it has moved to a prompt engineer, right? I mean, who can prompt better and get the best code is what the thing, right? Who can, I mean, you only need to know the codes. You don't need to code everything. So that is where things are moving. So that sort of, that sort of transformation paradigm shift is currently happening in due to the digital health thing. So tell students to get all the skills, and if they are like someone, if you're studying teaching, any of you teaching biomedical or anything related to health, tell them to understand how technology is adding value in public health, in radiology as a use case. I said the ethical aspects of it, and also if understand the data sciences, the languages used in, and get that, get them the habit of looking everything. What if AI is not there, and what if AI is there? Right now they have access to AI, so they may not, they belittle the, they think that AI is there everyone. But think about the time, right? Without AI, how things has been used, how things have changed. So that sort of mindset, that sort of interdisciplinary skills we have to build to the generation, and that is what would be very important. And this is a just quick thing which I want to before I going. So like India as a government is also, we are doing a lot of things. Some of you may be knowing National Digital Health Mission is part of it, and we have ABDM, Ayushman Bharat Digital Mission, comes under NHA, National Health Authority. So they are like, building a ABBA card, Ayushman Bharat Health Card. It's basically all the records of everything should be in one place. That is happening. So government of India is not behind in this journey. With our leaders and with our the visionaries, we are very much in the journey as it is any country. And I traveled to different countries to deploy our solutions. Something I understood is no country is like so ahead. Everyone is more or less same. And India is like, as good as US or any other country because of different reasons. So so that is something I can proudly say, as we are also doing very well in the digital transformation. And yeah, and my summary for this session is, AI is not the future, it's already here. So I encourage everyone to use AI. If you are not using AI, someone uses AI will definitely outsmart you. So start using AI for anything. Like, start with the basics of basics AI, which you are already using, but think of upscale it. Start with ChatGPT, then start with Perplexity, level up the use of AI. And like another thing which we want to understand is anything with AI is definitely better than without AI. So we just need to encourage the using of AI and to make sure we are moving to the right direction. And healthcare is, again, it's a very delicate and very very tricky area. So AI will be never fully dominating it. It would be always a balance of someone uses AI, someone who understands AI will lead the session. Now I'll take a pause here because I just want to any questions or anything. I know I went a little faster because of the time constraints, but I'll pause here. Like we can take any questions. Madam Janvi ma'am, if there's any questions anyone has, like happy to take it up.
हाँ,
Okay,
क्वेश्चन आंसर कर तो मैंने माइक चालू कर दिया माइक participants can
Hello, all participants. You can now ask the questions. Everyone's mics are enabled now. You can unmute and mute yourself. We can take up the questions now.
Hello, am I audible?
yeah.
I'm Professor Kinjal Magadia from Government Engineering College, Bhavnagar. Sir, as you said, everything is now data driven. Means healthcare is also data driven. So how can we
Okay.
decide whether the data which is given to the model is reliable or not?
Okay, so that's an interesting question. So how do we do is, we cannot take any random data to model, right? So there are 2 3 steps of it. One is we have to get the ground truth of the data. So ground truth means, so for example, I'm taking an X-ray image of a tuberculosis. So I have to, so before feeding that X-ray to the my model, I have to get the ground truth. Ground truth means I have to dig down whether it is an original thing, whether the someone has been confirmed it, some doctor has been confirmed, and some was there been validation on the data. So only after that ground truth validation, data is fed in an ethical practice. So that is what we need to do. Then the second thing is called annotations. Annotations are, there are paid annotators. So any data which I am feeding to this my system, so along with the data which I am getting, or if it is an X-ray which I am getting, the X-ray report I'm getting from the my ethical source of data, I'll also have an annotator looking at that data and validating and making sure whatever it is having 80% of concordance, because it's people to people. There would be 10 to 5 to 10% of different discordance, but at least 80 to 85% of concordance is minimum to use any data. Otherwise, it's an invalid or ineligible data. So even the data we get, right, not all of them are useful. So there would be a filter. 20% of data would be definitely invalid because for multiple reasons. So you're right, ma'am. You cannot use all the data. It has to be validated. It has to be ground truth and has to be understood. It has to be annotated. Then only it goes to a training stage.
Hello.
Yeah. Yes, sir.
Namaskar. Myself, Dr. Brijesh Mehta. I'm calling from Sasit, Surat
Okay.
College.
Okay.
Sir, up to especially what we discussed in the entire session, I would like to know that is there any, the expert advice is required or feed the data, means expert advice, like, when it concern about such kind of severe disease, right?
Yes, sir. Yes, sir. So, very valid question. So, what is happening in India or anywhere in the world? Currently, there are regulatory frameworks, right? In India, as per the regulatory framework, AI cannot communicate to patient. That is a clear no. Whatever it is, even if it is a cancer, even if it is a tuberculosis, artificial intelligence can only communicate to the hospital healthcare provider, that is doctors most of the case, and then the doctor or they are the primary user, they has to validate and before communicating to the patient or before communicating to anyone outside the system. So in currently any tool, right, any software we use in phone, we are the user, the software gives us the information directly. But in healthcare, that is still not enabled. We will be only validated by a expert or a if it is a radiology, it has to be a radiologist. If it is a something on lungs, pulmonologist, that expert has to validate, then only it has to go out of the go to the patient. So always patient, even though patient is the user, they are kept out of the loop, and AI cannot communicate to patient.
But sir, up to certain system, like expert system, like small disease. I'm not concerned about the very severe disease, but up to the small disease, is there any chances like expert system will be take certain decision, like predict the medicine, diagnose the disease, something like that, so that in future, what we should look, that in future the expert system should be provide the suggestion for a small disease, not for the severe disease, sir.
Understood, sir.
So
But the
AI should
problem
take.
is, it is not something decided by me or you, right? It is a policy decision. For example, India as a country, for example, with the recent ban of the gaming, right? So there is a lot of data, government, a lot of money government is getting through it, but still they went ahead with the banning of the online games, because from a policy angle, there are reasons for it. So AI can do things, AI can easily do it, but it is a policy call, and after the policy decision, there would be maybe 10 15 years or maybe 5 to 10 years, there would be primary health centers can, I mean, primary elements can be communicated directly. But at this moment, there is no regulatory approval for any of it. It's not only in India, anywhere in the world. So maybe in future it will come when, I mean, I'm also hopeful, but yeah, at this moment, it is not. It also go the other way around also. Maybe future, policy can decide AI is not at all needed, because anything can happen, right? I mean, future is very dicey, but something which I can say is in healthcare, someone uses AI is always better. So, for example, two doctors are there. One doctor uses AI for his radiology or his whatever it is. One doctor doesn't use AI. The doctor uses AI will be better because he has more access, more faster, more accurate. So that is how now the user is mostly the healthcare provider, not the patient. So we haven't reached a stage AI B2C. It is still B2B, and our B2B business is business to hospital or the healthcare provider. Thank you, sir.
Right, sir. Agree.
Good evening, sir. Dr. Dushan Patel from Government Polytechnic, Ahmedabad. It
Yes, sir.
was very nice session. I just want to ask about that chatbot of WhatsApp, August AI.
Okay.
I have used it few times. So how
Mhm.
much it is trustable? Because sometimes it is asking for the images also. Suppose there is some skin rashes or something. So we have to
Okay.
post images, and then on the basis of images, it predicts and it gives some suggestions. So is it
Correct.
trustable or like that? If you can answer.
Any AI tool, right? They work on the data. So, for example, image any image we are clicking. So, I'll tell an example before that. So, for example, we had a similar product for analog X-rays. Someone has to click an image and upload the thing to get the analysis. So, what happened is the quality of image, the angle you click the photograph, the way the phone you used to click the photograph, everything mattered, right? These are very external factors which is which is definitely which is going to decide the quality of image, the color of the image. For example, if you take a photo of a sari in and you look at the sari, so the color is different, right? When the actual, so that difference is going to be 5 to 10% of errors it could account. So that is where anything when we send or upload an image, there could be chances. The format, I mean, there could be human errors, there could be technology errors, everything would be there. So in healthcare, still, even if it is skin lesion or anything, we shouldn't, or we are not yet to take any AI solution directly and start treating ourselves. We have to validate it by an expert. Someone has to touch and feel it, or someone has to see and give a go ahead, because that is one, that is how regulation is. Then second thing is, it's as of it is not in the policy, we better we wait for some more time. And in terms of trusting, yes, it will work. AI will work. 90% it will work. But it would be better we just take a cross validation. So for example, AI say this is this thing. Maybe you can check it with the doctor or someone. That would be always better. And trusting is a personal thing. If you are comfortable, you are getting a thing and you can take it. But maybe as a policy, I'm not here to. I cannot comment that you should go and edit it. That is against the policy. We should wait for it.
Good.
Thank you,
Thank you,
sir.
sir.
Hello,
Hello,
sir.
sir.
Yes, sir.
Shweta here.
Yes, ma'am.
Sir,
Yes,
what are
ma'am.
the barriers to AI adoption in healthcare systems?
Okay, interesting question, ma'am. There are three, four adoptions. One is one is the trust and the kind of mindset. For example, even you speak to doctors or bureaucrats or IAS officers. So decision in India is a federal thing. Any state you go, any corporation you go, everyone has, right. The people who sits in that chair is taking the decision. So how well they are adopting, they are understanding, they are acknowledging is act as the first barrier. And now we take a decision, government say them to do it, and that person has adopted, and we go and deployed in the hospital. And how much they are pro to technology. I mean, even this, it's a very small thing. Some people do not want to use it, right? They are like very adamant, or they do not want to try it out. So that sort of mindset comes as the first barrier. And this is something which can be solved with trainings, regular interactions, but primarily it can act. Then the second thing is infrastructure. For example, anything to work, we need internet. So though we say internet is available across the country and in a very good settings, something we have noticed is if you go to hospitals, these radiology rooms or some of these rooms are behind the thick walls. So internet becomes an issue. So that becomes when there is a slow internet, just like we get fed up. I mean, it may take some time to upload and get the processing. People get fed up. So good internet is still an issue in some part of the country and some part of the world. So that also act as a different or barrier in adoption. Then the third thing is the maintenance, right? We can give the technology, we can give the thing, but if it is a software, if for example, if government in government of India passed a law, and hospital in a public primary health center or district hospital in Ahmedabad is using it. But someone has to take the ownership and maintenance it. So it's more of very personal and behavior at this moment, not of technology oriented. That is what is that act as the most of the barriers. Then also, infrastructure also act. For example, many of our government hospitals uses very old HMIS, old infrastructures, old X-ray consoles. So that also, I mean, when it becomes newer, it's easy to integrate. Old one also can be integrated, but very high likely to break it. Then many of the health systems do not have EMR or EHR. Health records are not digitized. They still write in pen and paper. So these all small things in the health systems are act as a barriers, and it is different to any hospital. Any different hospital has a different story, but universally these are the 4 5 I can think of.
Hello, sir. And one more question I need to ask, sir.
Okay,
Sir,
ma'am.
how can AI assist in managing hospital operations and resources, sir?
Okay, so see, in a hospital, so think you walking into a hospital. What you're seeing a lot of people walking through. So hospitals are operationally chaotic. So there's a lot of people. I mean, you may say that colleges are chaotic, but you go to hospital and you talk to some hospital people, they'll like literally they're tired. Like every time, everyone is chaotic, and everyone's schedule is messed up. Everything is there. So now, in an operational chaotic environment, people are already burnt out, people are already overworked. So now, what AI can do is AI can first start with getting an order to things, right? So, for example, I know, so if AI can predict in next this month, the pattern is like my bed occupancy would be 30%. So I can, I mean, now that so with this data, I can prepare myself. I can prepare my operations according to. I can make the duty chart according to it. That is how AI is going to add operational efficiency to the hospital, predicting outcomes based on the data patterns. So hospitals can prepare accordingly and make their efficiently use their operation. Second thing is I said is revenue generation. If you recall my session, so there is like a lot of money is going on human resources. If we are like there are a lot of things, right? I mean, for example, consultant doctors, right? We are reducing their time to use in the hospital, so the hospital can actually cut the cost, increase the revenue. So cost to revenue is something that AI can use. So these are the 2 3 things which we do. The another thing is time management, right? And any doctor or any hospital, anything, any work you do, instead of 20 minutes, you do it in 2 minutes, you're saving 18 minutes. That's technically your money, and you can invest into both, invest into something else. So that is the money saving, time saving, and also resource optimization is what AI can do in hospitals. And it is every hospital, the workflow and everything is little different. So there's no standard workflow, but AI companies has to understand what the pain points, then has to solve it. It is also a journey which there are companies currently doing it. But yeah, good question, and this can be a good
Okay, sir.
case
Thank you
study.
very much. And the last question I need to ask this, sir. This is the last question. So, what's the future of AI in global healthcare? What's the future?
Madam, future is very bright. So what is going to happen is AI is going to be, as I said, it's easily scalable, right? I mean, it is cheap also. For example, it is not as expensive we think. Once I build a solution, once I build an algorithm, the money which I give to my R&D engineers to build it, once it is built, there aren't much of maintenance or work I need to do. So it's readily available. It need to do some updations and some model upgradings we have to do, but the fundamentals of it is not very expensive. So that becomes it's easily scalable. So across the globe, any product which is solving problems can be scalable. So the future is very bright. With the power of AI, things can be fast diagnosis, accurate diagnosis, and also easy to use, and everyone will be equipped with AI. So that is the thing. That is why AI, future of AI is very bright. And anyone, even if you are not in healthcare, into healthcare, it's always good to have some sort of AI fundamentals, for your career aspects also. Thank
Sir,
you, ma'am.
thank you very much. And what are the ethical concerns, sir? For
Madam, ethical concerns, I think I mentioned, right? It is
yeah,
patient
yeah.
privacy, data, right? I mean, who owns the data is the question. So if you are going to a hospital and AI is examining you, you have the right to know that. So right now, there are regulatory bodies to that, but again, I mean, we need to have more ethics, more policy come on this, and maybe in next 2-3 years we'll see a lot of policies. DPPI Act is coming, so with that, more policy framework will come, and we will save more lot of things. So if you want to know more about the ethical concerns, you can read about Sprinkler versus State of Kerala. Sprinkler was a data company which took the data from the state of Kerala, and Kerala had an issue, and that project got stalled, right? So that is where ethical issues, right? Whose data and whether this data is used for something else. So that is the primary ethical concern for any AI organization in healthcare.
Thank you, sir. Thank you very much.
Okay. Madam, if there aren't any questions, we can wrap up.
Good evening, sir.
Okay, yeah. Yes, please go ahead, sir. Sorry.
Am I audible, sir?
Yes, sir. Yes, you are audible, sir.
Okay, I have a question. Say some AI model in healthcare is built in United States.
Okay.
Obviously, on the patient data of their country, and the thing is, in our country, maybe patients have some different clinical parameters, height, weight, hemoglobin, etc. Maybe some different parameters. So their model, which is built, which is trained on their population, will it work in our country at the same accuracy level? That is my question.
No, so a very, very valid question. Not always, right? For example, Southeast Asia, you first of all, there is the trait of people is very different now. Even if you go to US, you have Indo-Americans, Afro-Americans, Hispanics, Latinas, everywhere, right? I mean, US is a very multicultural country, as you know, and same with India. So the difference between any country and their population is very very debatable now. Any country you go, you see a lot of people in different traits and different things, different height, different biological features and everything.
Yes.
But again, the question you put is correct, because some example, the climate and the way they live, right? For example, Canada, Russia, all these people, they have very different, I mean, their blood itself is different, because their hemostatic is very different, and they have a long winter seasons, long summer seasons. So when some parameters, it won't work with the same accuracy, right? It will affect, but it is not a deal breaker. What I meant by deal breaker is that doesn't solve you in solving the problem. What you need to do is you deploy the solution. If for example, if I build the product with mostly using 60% of data set in India, and I have to deploy it in Europe, the same product I can deploy in Europe. And what I will, when any company, what they will do is they will assess the new data coming from that specific place. Maybe for a time frame, they both will agree, the client and the product provider, maybe 6 months or 3 months. Then they adjust the threshold accordingly. For example, so threshold are built. Now you just need to tweak the thresholds, right? For example, so you deploy it in the real life settings, then observe the data patterns, then adjust the threshold, because the model is going to be similar. It's only a matter of tweaking the thresholds. Okay. That is how there would be minor inaccuracies which can be resolved. That is in a nutshell.
Okay, thank you, sir.
Thank you. Thank you, everyone. Janvi ma'am, I mean, we are done. We can wrap up the session then? Hello?
Hello.
Yeah.
Hello.
Yes, sir. Yes, sir. Tell me.
Yes, sir. Completed, sir.
Yeah. We can complete. We can wrap up the session. Thank you.
Okay,
Thank you, everyone. Thank you for giving me the opportunity. Thank you.
Okay, sir.
Thank you.
Thank you, sir. Hello, everyone. Uh, we have 5-10 minutes before we can start our next session. Let us wait for 5-10 minutes. Our next session will start by 8 p.m. most probably. Welcome everyone to our second session of the day. Dr. Kiran Trivedi has already joined. Let me introduce him to all of you. Dr. Kiran Trivedi is an associate professor of computer science at the University of Wollongong, Gift City, Gandhinagar. With over 20 years of academic and research experience in India and the USA. He has previously served as Northeastern University, Satil, and Gujarat Technological University. Holds a PhD in human brainwave analysis and is widely recognized for his expertise in artificial intelligence, edge computing, and deep learning. Dr. Trivedi has delivered invited talks at leading global platforms, including UNESCO in France, ICTP Italy, and Georgia Tech USA, and has published more than 35 research papers along with 2 patents. His contributions have earned him prestigious honors such as the Nokia Developer Champion title, the Dr. APJ Abdul Kalam Innovation Award, and the Patient Value Award from the University of Wollongong. He has also received NVIDIA AI research grants and led students team to success in state level hackathons. Beyond academia, Dr. Trivedi is an avid cyclist with over 27,000 kilometers of riding experience, a music enthusiast, and a passionate advocate for innovation and student empowerment. Today, Dr. Trivedi will be sharing his insights on Gen AI, generative AI with TinyML, highlighting current developments, practical applications, and future prospects of this transformative technology. I would now like to invite Dr. Kiran Trivedi to take over the session. Dr. Trivedi.
Thank you. Thank you, Janvi, for the
Thank you
introduction,
very
and
much.
pleasure being with all of you. And it's happy to see that like more than like 184 participants are there in this FDP at the very late evening today. And I will try to explore as much as I can for all of you, and will try to demonstrate something. So being, I think, one of the last session for today's first day, is it the last one, right, Janvi?
Yes, today
So
it's
I'm
today's
I'm going
last session.
to
Yes.
make it some interesting and something like I'm going to demonstrate something hands-on, as well as some of the devices which I have and some of the projects which I recently did. So there would be a mix of PPT as well as some live demonstration, what you can do with generative AI as well as TinyML. So let me share my screen first, and then we'll start my presentation.
Okay, sir.
I hope you can see the screen, right?
Yes, sir, we can see your screen.
Okay. So right now I will little bit modify the title. It's generative AI and tiny machine learning, basically like how we can use it on wearables having an AI capabilities. And again, it's going to be related to voice driven intelligence on edge devices. So before I start my session, let me tell you something about different terminologies like what is generative AI, what is tiny machine learning, or maybe edge computing, etc. So in general, by and large, when we talk about artificial intelligence, it is all about when we do collect the data and then train the data with some sort of mathematical model and try to bring some model out of that. And when we inference them, or maybe when we use on the computers, that is a normal AI. But when it comes to an embedded system or an electronic chip, where we transfer the model to a very smaller size of the hardware, where there are lots of resource constraints are there, maybe a low computing power, low battery power, or maybe the memory storage, etc. The flash memory is also very less. So in such scenario, if we can run such model, it is basically a kind of a tiny machine learning. So in general, normal machine learning and tiny machine learning, the biggest difference is in the size of the model. So if you take an example of a computer vision problem where you might have a model of say 150 MB, which has been trained on number of images. But when you want to use it for a very small Arduino kind of a device where
limited resources are there. So you transform that model to a very smaller size, maybe a 9 kilobytes or 12 kilobytes of model. And that is why it is known as a tiny machine learning. So the recipe or the ingredients for machine learning remains same, but it is all about reducing the size of the model and loading into a chip on a standalone device, or maybe a kind of a handheld device, or maybe wearable device, whatever you name it. So we try to replace the computer with some embedded system, or we try to load it on a maybe a small chip where it can run the model and all the capabilities and functionalities can be achieved. So that is what the tiny machine learning is all about. Now we call it as an edge computing also sometimes, or sometimes we call it as a physical computing. So why do we call it as an edge computing? It is because when you have a full network, say for example, we are connected with internet, there are lots of IoT devices, most of the things, even our mobile phones and everything are connected with internet. And when we use AI systems, basically there is a central server which has a number of models running, and they try to process the information whenever we send it through our devices. It could be anything like mobile phone. Whenever we say upload a Google photo to our Google Drive or maybe Google Photos, the models are running at the Google server. And finally, it can find out that what are the contents in the images or what are the objects in the images. So you might have observed that if you open your Google Photos and try to search some images with say bicycle or maybe sunset, etc., the model will be running at the Google server and will find you the solution for that. But when it comes to edge computing, it is at the edge of the network. So say for example, again, the same internet, same devices, everything is there, but the model runs on the device itself. And the best example is the Amazon Alexa, what we use at our home. So the model is basically located or stored or running on the device itself, and it processes everything. So the concept of edge computing is all about running the model on the edge of the network, on the edge devices. So Amazon Alexa, Google Home, or maybe Siri, or any other devices, like you have chatbot applications or voice chat devices. These all are basically the edge computing devices, and the models are running on the device itself. The reason is that we want privacy. We don't want to transfer our data to the server. Everything should be processed on the Alexa device, for example. And again, whenever some information is being transferred to the Alexa or maybe Amazon servers, there is a kind of an encryption. So recently I met one of the Amazon engineer from Seattle. He told that whenever you are using your Amazon Alexa at your home, you give some instruction that Alexa play my music, for example. But when it goes to finally in terms of processing for some sort of, other maybe a future enhancement of the model, they actually transform the complete audio into a different encrypted form. So they never know that who are the users using our Alexa devices. So there is a privacy, and most of the things are being processed on the edge computing at the devices what we have on the home, at the home. So today's session, like I have divided into different part. Initially, just to make some curiosity, I'm going to demonstrate you something, and that is recently I demonstrated one of the Festival of Australia event at various places in India. So I will show you that first. You see different three images over here. So what I've tried to explain here is that, say for example, we human normally communicate, right? So maybe there are two friends communicating, or maybe in our day-to-day life, since morning till we sleep, we talk a lot and we do lots of conversation. So it is all about generating audio, generating speech signals. But sometimes it is necessary that we need to remember those things, that, okay, like I got a call from someone from GP Ahmedabad that you have a lecture today at like 8 p.m. in the evening. So there is a conversation happen. So I said, okay, I will join at 8 p.m. But sometimes it is necessary that we want to log the audio for ourselves and we want to process it further. So here is an example of how it has been done. So consider that these two like images being generated through AI, like there is a boy and girl. They are wearing a wearable device which has a camera, which has a ESP32 inside that, and number of things have been included. So if you look at the first boy image, it says that last week you said you want to go to gym. So maybe if you ask that device that, okay, last week what I was talking about, so maybe your device can tell you that you are talking about going to gym. Or maybe at the end of the day, you ask your device that, tell me about summary of today, what I converse with different people. So maybe it can give you lots of, contextual statements from your daily conversation. And again, there is a kind of a privacy being, it's a privacy preserved, I should say, so that it will not record someone else's voice, because we don't have any right to record someone else's voice without the permission. So the device is designed in such a way that it will record only the sound of a person who is using it. So for this girl, like summary of your days, like you paid the fees, you have party tonight, or maybe you are applying for UW India. This is based on the conversation, what has been done so far. But it is not that simple. What do we think? That it is not simply recording them. It uses lots of various services of generative AI to bring all these to a single device. So let us look at the diagram, how it works. Let's say, for example, there is an ESP32 board, or maybe any variants, like maybe you have a Seed Studio, the Zao device, or any other device is what you have. Maybe it has a camera. So what I use is I have a DF robot board here with me. I will show you that. This is the board which I am showing you right now. But if I can show you on the camera, you can see this one. So this is a DF robot board. It has a camera on board. It has a microphone on board. It has loudspeaker on the back side. Even there is a memory card. So whatever I'm going to speak will be recorded on the device itself. Are you able to see this one, or the screen is being shared and that's why you're not able to see that? Okay, fine. Thank you. So let me maximize this one. So what happens, like whenever we are using this device, say a kind of a wearable as a necklace or maybe a wristwatch, the audio will be recorded at some seconds of interval, maybe like 2 seconds, every 2 seconds, or whenever the audio, when the audio is detected, it will start recording. So initially it will record the file, but we need to record into a WAV format. So initially the file on the ESP32 board having a memory card, it will be stored into a WAV file format. Now, once we have obtained the WAV file, we need basically a text because we need to process this text. So finally, there we need a transcription of the text. And if you are aware about the DeepGram servers, they basically provide you lots of voice intelligence. So if you open a website of DeepGram, you create your account, you get some free credits in the beginning, or if you have a plan which has been purchased to use the DeepGram officially, or maybe like if you want to run some business on that, you need to have some sort of credits with you. So using API call, all these WAV files may be recorded for 5 seconds or 10 seconds will be sent to the DeepGram server. If you look at the block diagram, there is a cloud shows that there is a DeepGram connectivity. And once it goes to the DeepGram server, DeepGram has a feature that it will identify the audio file and it will transcribe into text. So basically you will receive a text file back to your memory card into the ESP32. Now, once we have received this text file, we need to analyze, we need to summarize that. Say, for example, if you provide a 2-page of conversation with someone you were talking and it has been recorded into a WAV file, we need only a summary, or we need only simply a context of that particular conversation. We don't need the full, text of the audio which has been generated through conversation. So basically it has to be sent to the OpenAI router or maybe OpenAI server, where basically we are sending it to the chat GPT, but we are not directly accessing the chat GPT, but through OpenAI router, we are sending this text to the OpenAI router and it will finally give you some sort of contextual meaning. If you're asking something, say, for example, what is the capital of India? It will be recorded into a WAV file. It will go to DeepGram server, converted into a text file. You will receive back the text file with some sort of, the time stamping and everything, maybe the voice intelligence, sentiments of the voice. The DeepGram will give you a lots of information in terms of what was the tone of your voice, basically the sentiment, whether you were neutral, whether you were happy, whether you were angry. It will also identify all those things, and the text file will contain all these information once it is stored. So now we have received the text file or maybe a summary from the chat GPT of all the conversation or whatever question has been asked during the conversation. It will give you the answers to. And now we need to play it back on the device which we are wearing. So whenever we ask a question that tell me about my 6 months of conversation summary, what was my sentiment, whether I was angry, whether I was neutral, whether I was happy, etc. So you will get all these through 11 labs. So 11 labs will give you a kind of audio output and it will send you a WAV file, and WAV file will again be stored on the memory card on the ESP32 board. So the DF robot which I'm using here. So that is one way of doing a kind of using an edge computing device or a tiny machine learning device or a very small resource constrained device and using generative AI on that. So we are running everything, but we are using API calls. We are using number of API services, and finally we are able to do this. So let me show you the demonstration first. It has been programmed in Arduino. Right now it has been connected. If you can see my screen, let me start it again. So right now the board is not connected. So if you can see that it shows Wi-Fi connected. Even I have like added number of features into this one that I can get the timestamp, the date of today. Right now it shows the different, yeah, Monday, September 8 is correct. Time is not correct because I have not converted into an IST time. It's basically a GMT time being shown using the internet time zone servers. Now what I will do, I will store the audio for say few seconds. I will ask a question. So if you can see my camera, I'm going to press the button to record, because until and unless you do not keep the press button to record, it's going to record all the things all the time and it's not going to work. And that is why whenever we want to record it, we will press it. So say, for example, what is the capital of India? Save to wave to SD card. So a file which has been recorded has been saved. Now it is sending it to the DeepGram server. So the wave file will be transferred from this device to the DeepGram server. It will be converted into text or transcribed. Maybe sometimes it takes time, or I don't know, sometimes it gives you an error also, but I will try again and you will be able to get the answer. Okay, so we got something from the DeepGram, the detected language. Right now it's not given. Sentiment is also not received. And here it has taken the language because I have changed the settings to Spanish language and it got something different. But again, TTS wave saved, that is through open router. So what I will try to do, I will record it again, or I need to change the settings into my DeepGram server. What is the capital of India? Okay, it's doing again. What is the capital of India? Let me open this DeepGram account and I will show you. So everything is recorded properly. So it shows my internet is poor and slow upload, and that is why there is an error message. But what we get usually, because right now my DF board is connected with my mobile phone's hotspot for the Wi-Fi. And finally, whenever we get all those things, if you look at the memory card, we open the memory card, connect with the computer, you will be able to see that the answer from OpenAI router has been received into a WAV file format. Even the sentiment analysis and everything is possible through this one. So now coming back to the PPT and show you how it works again. And there is another option of using ESP32 instead of this sort of DF robot. I have another option of showing you just for your students project. If you're interested, you can use them for the students. That is basically a kind of a wristwatch. It's similar to an Apple Watch, not a kind of an Apple Watch. It is just for like 3,500 rupees, but you can use because it has an inbuilt ESP32 microphone, loudspeaker, memory card, everything on board. So you just need to wear it and talk to your watch and you will be able to get that. And this is the box. If you purchase, it is by Liligo T-Watch S3 basically, and it gives you all the option to program. You can program it using Arduino board itself. Arduino's IDE, I should say. So this is the one detail about the ESP32 T-Watch S3, where you get everything. There is another variant of this one which has an inbuilt GPS also. So maybe you want to record, or maybe you can ask your wristwatch that, okay, what I talked near Sindhu Bhavan Road on Saturday. So if you are there, it will identify the GPS log and everything. And basically based on that, it will be able to provide you the context of the conversation. So in short, like if a student is wearing this watch in the classroom, He will not have to take any notes. What teacher is teaching, everything will be recorded. If the permission has been provided by the teacher to record the audio, then he will be able to record everything. It will go to the DeepGram server, will go to the chat GPT, will give a summary of the what teacher has taught in the class. And finally, he will be able to even recall at some future time whenever it is required, maybe during the preparation of the examination, etc. So that is how it works. And I have created a very simple demonstration video. So this was again generated through AI. I gave some prompt about this project which I was demonstrating, and it was like just we got back in terms of all these video kind of a format. Anyway, so that was the first example of how we can use a normal ESP32 board, which has a capability of running machine learning models, and even to access the lots of generative AI capabilities of various services. So in this example, I use services like DeepGram, Open 11 Labs, as well as OpenAI. So all of these three communications were happening with those three different servers through this board's Wi-Fi, and it was capable of doing everything successfully like a computer. So that is what the tiny machine learning or maybe the edge computing is all about. Now, another example I would like to show you here is I usually show this to the students, basically that how you can use or maybe identify various smells using AI. So like usually what we have done so far, that as a human, we have all the intelligence, like we have number of sensories. We can classify even the smell. If something is being cooked in our home, we can identify what is being cooked and what is the name of that particular recipe or maybe the items which we are cooking. So how we can enable such thing using the same classification of various smells using a tiny machine learning model, or how we can do that. So that is why I have prepared a 2 3 slides of that. And fundamentally, it is all about the human olfactory system, that we have some receptors, and from receptors, the the brain actually identifies various different smells. So how we can achieve such thing, I will go quickly with some of the slides and will show you how it has been done so far. Yes. So this is what I did when I was at Northeastern in Seattle, and I will show you. So this is what you can call it is an AI sniffer. AI sniffer is like a dog who can sniff various smells. So dogs can identify a kind of, any explosive, but we cannot identify because we have limitations. So how electronic chip or maybe through sensors, we can identify various smells using AI, creating a small machine learning model, deploying it onto an Arduino, and finally we can find it out. So here I have used a VO terminal and some sensors from Grow. These are all basically Seed Studio sensors, multi-channel gas sensors, SPG and CO2 gas sensor, as well as temperature, humidity, and pressure sensor. Why we have used temperature, and humidity sensor here is because every smell is dependent on the humidity as well as the temperature. Usually what happens when there is a rain, we get a smell of, soil and everything. Just because of the humidity is very high, we are able to smell those things. And that is why for every smell, the humidity matters a lot, temperature matters a lot. And basically when we are taking number of readings all together, we should be able to find it out. So I will show you these sensors, what these sensors are capable of doing. This is a GROW multi-channel gas sensor, which can give you CO, nitrogen dioxide, ethanol, hydrogen, ammonia, methane, and or all other various gases into a single board. And even multiple gas detection can be done through this one. But very important part is basically the volatile organic components. Whatever smells, whatever things we smell, that is just because of the volatile organic compounds. It means that whenever you cook something, there are VOC particles which actually travels through air and it comes to our nostril, and finally we are able to understand those things. Things which cannot generate VOC particles, we can never smell them. And that is why we need to have a VOC sensor here. This is one of the most interesting and important sensors for identifying various smells. These sensors are not capable of finding out the smell, but it can give you the VOC level of different smells or aromas. Say, for example, if you have a coffee cup, you put the VOC sensor over there, you will get some data on the serial monitor of the Arduino. If you put a tea over there, you will get a different reading for the VOC outcomes of those tea fragrances, everything. So this is the most important sensor. Fundamentally, it is basically giving you an output in terms of volatile organic components as well as the ECO2 kind of a thing. So equivalent carbon dioxide value. And this is another sensor which I use for temperature and humidity because we want to measure it. Say, for example, to create a machine learning model, you might have recorded number of data. So maybe right now in this room, if the temperature is say 24 degree, and if I put a coffee cup here and take the readings of those coffee smells through VOC sensor, it will record with the temperature of 24 degree. Now, if I train that model, put it onto an Arduino chip and run it somewhere else in the 40 degree, it's not going to work. So I need to have a variety of data. More the data you have, more the diversity you have, more the accuracy you will get. That is how it works. So you need to record into different temperature conditions, different humidity conditions to make it more universal, and it should work in any of the scenarios. That is how it works. So this is something, the hardware connection, what I have. This is the VO terminal basically, which you can connect with the sensors. And it is again, you can connect with Arduino IDE and connect it. So it's basically, I call it as a sensor fusion. So you have various different 3 types of sensors. You are collecting those data and finally you are classifying them. So in general, the fundamental scenario is basically what we are going to do is classifying the sensor data in terms of various smells, what we have actually stored the data or collected the data and trained them and created a model for that. So it is for various, spirits, like whenever you have different spirits, you can even identify the VOC because every spirit has a smell. And whenever you get it on the serial monitor, you get the timestamp, temperature, humidity, and CO2, VOC1, VOC2, nitrogen dioxide, ethanol, carbon monoxide, all of them. So you need to just put it for a few seconds, collect all the serial monitor data, put it into a CSV file, label it as a like coffee, and again do it for say tea or maybe some other materials what you're trying to test or classify for various smells. And then we will do the classification and we'll do a kind of a machine learning for those different smells. And the best part which I use for here is like I use a Age Impulse platform. I think many of you will be aware of using that. It's a kind of a no-code solution. You just need to upload the data. So if you look at the collected data for tea, chamomile, kind of a very different fragrance of tea, the data were collected for that. The data were collected for various different tea smells here. And then finally, we need to do classification. If you don't know AI or machine learning, it will give you a guidance in terms of what sort of data you have. It will provide you a kind of a hint that you need to do Keras classification model, neural network classification. If you want to do anomaly detection using K-means clustering, you can go for that also. And finally, you go to various steps. Like if you look at the left side of the screen, initially you have a dashboard, then devices. If you have connected your device directly with the Age Impulse through your computer, it will start recording the data and it will upload. If you have a CSV file, you can upload the CSV file to the Age Impulse platform and you will be able to create it. And finally, it comes to the impulse design. Impulse design is nothing but creating your own model or making doing the training for those data. So go one by one. If you want to flatten the model, if you want to do neural network classification, if you want to design the different layers as your own, by default, the Age Impulse will create a model, training model, and it will give you various parameters. So for example, in this case, the default value of the number of training cycle was 300. You want to change it to 500, you can do it manually. Otherwise, it will optimize and identify number of layers, dropout layers, dense layer, etc. But you can definitely change them, and you can edit the code even. It will show you the code for these buttons which are being displayed here on the screen, and you will be able to modify that as per your requirement. But by default, whatever Edge Impulse gives you are mostly the optimized ones. So there is no much scope available in terms of improving the model. And once you do, you can see this sort of, confusion matrix, even the classification and everything. Here, the accuracy is also being shown. So without writing a code, you can even create a complete model. If your data is ready, within few minutes, you will be able to run the model on the Arduino Nano itself. So once you are done with the classification and training and everything, it shows you on which board you want to deploy your model. So it gives you in terms of, say, for example, if you want to create a C++ library for your model, maybe a normal model, you want to run it on your computer, you need to download the C++ library. But when you want to use it on Arduino, it should be a kind of a, um, I should say, transformed into a very smaller size or truncated model, which will basically give you a very smaller size of the model. If you are using some sort of NVIDIA platform like NVIDIA Jetson Nano, you need to convert into a tensor library, tensor RT library, because NVIDIA supports tensor RT only. Or maybe if you have another board, you can even explore those variants and you can create a library. So whenever we will create it for Arduino, we will basically get a .h file. It would be a header file kind of a thing, and you need to import into your Arduino code and you will be able to get it. So when I tested this with the coffee smell, I put all the sensors inside a bag, because usually what happens that because of the air or the ambient condition of the environment, the smell is not that much prominent. So if you want to provide this sort of smell, because these are machines, these are sensors, they don't have human sort of intelligence. But whenever you put it, it will show you the accuracy that it is 97% coffee. Maybe when there is no smell at all, we need to collect the data for background also. Background is something ambient kind of a smell. Whenever we enter into home, maybe whenever we are sitting at some places, there is some normal smell which is existing. It cannot be of any of the material or maybe of any of the object, but it could be a normal background smell. And that is also we need to collect, because whenever you are not putting any of the test condition, it should show you that, okay, there is no smell at all. So I'm displaying here background, but that means no smell. 80% there is no smell found in the environment. So again, if you improve, you can get 99% of accuracy. It was done for various alcoholic content also. So it shows you various combination that coffee was one, but for other spirit, gin, etc., it was only 0 because it was not there in the room at that time. And if you want to learn more about this one, you can refer Benjamin Cobb's artificial nose project. I have taken everything from that particular project and has made my own kind of a collection of the data for various objects, and it was working perfectly. And you can even make something else out of this one for, say, for example, explosive detection or anything else. And you can make some devices which can be useful for the military purpose also. So this was one demonstration. But before moving to that, I will show you in another one how various devices can be used for tiny machine learning, as well as you can use it for your own projects. I'm not going to cover any AI/ML fundamental part here, but I will show you how you can do it. So this is one of the everyone's favorite Arduino Nano board, which is a little bit different than the normal Arduino Nano. It is basically 33 BLE sense, which has number of onboard sensors. So for machine learning applications, it is better to use this board because it has a capability to run this board, because it has almost 256 kilobytes of RAM, and it will be able to run everything perfectly, because most of the models are of 8 kilobytes. So if you look at the board, it has color sensor, brightness sensor, proximity sensor, gesture sensor, digital microphone, motion, vibration, orientation sensor, so kind of accelerometer, gyroscope, temperature, humidity, pressure, and everything on board. Even it has a Bluetooth on board, so you can connect with your mobile app if you're trying to transfer the data through that. So whenever we use this board, what we try to do, say, for example, if you want to make your own Amazon Alexa kind of a device, the yes and no identification or audio classification, who is speaking in the family, what language being spoken, this sort of experiments you can perform with collecting the data through this microphone, and you can even classify them, and it works perfectly on this board. It comes with a camera also. So I will show you this board, and camera module comes with that. So this is basically the board which I have right now connected with my computer, and I'll be able to show you that too. So this is Arduino Nano 33 BLE Sense, which has number of sensors on board, microphone, and all those sensors which I show you. And this is the camera module which comes with that. So it comes with a kind of a development board. You fit this board onto the development board, and you can connect this camera. So you can even develop a computer vision based application. You can even take attendance in the classroom by collecting pictures of the students, and automatically it will log into a CSV file, and even you can find out number of things, or maybe the classifying various students, etc. Let me go back to the slide. So even you can do object classification or object identification through this camera. Right now it is through a screenshot of the mobile app, but even you can use the TensorFlow Lite model on the Arduino Nano board itself. So if you refer a link on the tensorflow.org for microcontrollers, you'll be able to get all these examples which I'm right now showing you. It can help you to even classify the speech, even you can find out a person identification and other experiments also. So this is the board which I was showing you in a very close view. If you can see the blue square, that is basically microphone, yellow square is basically motion, like 9x is IMU. And green is temperature, humidity, and pressure sensor in a single sensor itself. And now going back to this slide. So how you can run this, what setup you need to do. Initially, you connect your Arduino Nano 33 BLE with your IDE and find out this board. Go to the board manager and find out that. And once you get that, install that board. And after that, you need to install the library for various sensors. So for IMU on Arduino Nano 33 BLE, you need to search for LSM9DS1 library. For microphone, you need to search for MP34DT05. Everything is provided on the Arduino website, but just showing you that to make it run on the Arduino itself, or the IDE which you are using, you need to install all these library. Even you can find out gestures like left, right, up, down, close, far, etc. Pressure sensor, usually we don't use it for most of the projects we make. But digital proximity is very important. Ambient light is also very important. Even without the camera, you can classify various fruits. Like say, for example, banana is yellow, apple is red. So using color sensor, even if you can make a color classification model, whenever you put that particular fruit close to the board, it will identify the color and it will tell you. But it may not work for all the fruits, because if you show an orange, it will tell you a banana. So you need to collect number of data and identify various colors in a number of data should be provided. And how we can collect all these data. So if you know machine learning, if you can program them, if you can collect the data, train the model, then it is fine. But if you don't know, you need not have to worry, because Age Impulse is one of the best platform right now. Without coding, you can do everything. And even if you don't know what next step I should do, it will tell you what you have to do. So if you go to Age Impulse website, the first thing is that collect the data. And if you don't have a sensor, even for example, right now you want to make an accelerometer project, you want to collect the data for various motions or maybe various gestures through accelerometer. You are generating some data and you are collecting those data, and you don't have an Arduino. So what you can do, you can connect your mobile phone through Age Impulse, because it gives you an option to connect your mobile phone also. It will show you a barcode. You just scan that barcode and your phone will be connected with the Age Impulse account. Now you just move your phone, because it has an accelerometer inbuilt inside the phone. You will be able to generate the sensor data, and it will transfer automatically through internet, and it will be stored over there. And then you will be able to classify them, train them, and you can even deploy them once you get the trained model on the Age Impulse platform. You can download it for Arduino, you can download it for Jetson Nano, and then you can use it. So this is the first home page. Whenever you create your Age Impulse account, it will ask you to select the project. If there are no project existing, you need to create new project. The project will be created, and then finally it will ask you that what sort of data you have, whether you have an accelerometer data, whether you have audio data. Say, for example, you want to do classification. That on DD News, we have various channels like DD Gujarati, DD Punjabi, DD Odia, DD Kannada, etc. You are recording some audio from those news clips, simply downloading into an MP3 format or maybe a WAV file. And you want to classify that if someone speaks in Kannada, my board should be able to tell me that this is a Kannada language, or maybe this is Gujarati language. So in that case, you can use the audio option. If you have various images, maybe you want to classify all the students. and you want to identify the students with their enrollment number or maybe with their names, or maybe you want to connect with the GTU result website. So enrollment number will be identified for that from the student face. It will go to the GTU website, it will fetch the result, and you can even identify just by putting a camera in front of the student face, you'll be able to get the result of that particular student, that how many backlogs the student is having. And even you can fit it into a wearable glass, put the Arduino camera, everything inside a 3D printed wearable glass, go to classroom, and it will tell you in the audio format that, okay, this student has like almost 9 grade, this student has 2 backlogs, etc. So you can make some innovative projects using this one. And even if you have something else, you have other options to do that. So here, this shows that, okay, once you have already collected data, then it is fine. But if you want to collect the data through Edge Impulse platform, you have all the options that you can use your mobile phone's microphone to collect the audio data. You can use your mobile phone's accelerometer to collect the data. You can use your mobile phone's camera to collect the data. So even a single mobile phone will serve the purpose of Arduino or any development board. You don't need to buy anything. Initially, you can start with your phone, and you can even transfer the data to Edge Impulse platform. If your computer is connected with various sensors, maybe through USB or maybe through other options, you can use your computer to collect the data through webcam, through microphone. Even you can connect that too. And data from any other devices with data forwarded, because if you have a kind of a instrumentation process where data forwarding mechanism is there, which will forward all the data to the USB port, you can connect that. If you have a CSV file, JSON format, PNG, WAV, or MP3 file, you can upload all these together directly from the computer. So it means it gives you all the options to play with the data. And then after, you need to set up some sort of command line interface into your computer, download some dependency based on the GitHub link provided on the Edge Impulse website. Your computer will be ready for any of the tiny machine learning project. So these are the things you need to install on your computer. Like if you are using Windows, you need to install Python 3, Node.js, some Windows user for like, it will ask for some additional dependency, and maybe finally the command line interface tool via npm install for Edge Impulse CLI Force, because that is the proprietary installation required from the Edge Impulse platform. Because finally you are going to connect your laptop, maybe you are going to connect your mobile phone with the Edge Impulse platform, and that is why it is required. So these are the steps where these are the libraries available. If you go to Arduino's website, you will get all the details. So there is a complete wiki available. You can refer that. I just put the screenshots here just to show you that where you can download Python, from where you can download Node.js, etc. These are very older screenshots, maybe taken few years back. So now it must be updated one. And how you can collect the data or sensor data from the web browser, that is also an option. So what I will show you here, say for example, right now I have connected another Arduino board with this one. So previously it was connected with that one, but I also connected an Arduino with my IDE. This is connected. So now I will take this one and I will show you. See, if I'm moving this board, it generates number of accelerometer data because it shows me the AX, AY, AZ, means acceleration in X direction, Y direction, and Z direction, as well as the gyroscope data GX, GY, GZ. So all of this data can be available here. Now, if I do a gesture for 0, for example, if I do gesture for 1, if I write something like A or B or C, and if I collect number of data from different people, from myself, with a various different, uh, movement, say if I write A, someone can write a very big A. So I need to have variation in all the A which has been written in air. And if I collect the data through serial monitor, copy them and put it into a CSV file. And if I give a name to that CSV file as A.csv, so it means that these are the data of accelerometer for a gesture of A. If I do something for B, if I do something for C, or maybe if I do any other gesture, like say, I do something like drinking, I do it for say 50, 100 times, I will be able to generate the data and I will be able to finally classify them through the Edge Impulse platform. So the method and process will remain same. Instead of classifying the audio data, you are classifying the sensors data. And finally, you are creating a TinyML model, which again, you can deploy it onto a uh, Arduino Nano 33 BLE or any other DF robot boards which you have. So let me show you a waveform of this one, if I can show you here. So even you can see the patterns of the data whenever you are moving your sensor or accelerometer. You are able to see that some continuous patterns are being repeated, and that is what basically we try to identify through this classification or maybe any machine learning model. Right now it is not showing me. Let me do it again. See, if I do something like this one, it show me a continuous pattern. If I do something like this, it will show me a different pattern. If I do horizontal up down, if you can see that the value of different like AX, AY, AZ being changing. Right now, the pink color is basically prominent in terms of this waveforms. But if I change from horizontal, it will it will give me a different sort of waveform. So basically, we are trying to find the patterns from the data and we try to find out gestures. So if you look at your Apple Watch or any of the smartwatch which you are wearing right now, whenever we do a gesture like showing this one, it glows the LED. So basically there is a ML model which is running inside the smartwatch that whenever we do a twist of the wrist, basically it will enable that LED backlight and finally we will be able to read the time. So that's the best example that you can show your student that maybe how you can enable something with a wrist movement or maybe through any of the different motions or gestures, and that is how it works. So that was one example for this one. And again, I will show you another one, which is already there on this one. So a few years ago, like when I was at VGEC, we had won a global hackathon for identifying mosquito wing beat sounds. Through wing beat sounds, we were able to identify the mosquito species. So let me tell you briefly about this project. We actually downloaded a data set of various mosquito sounds in terms of wing beat sounds. I mean to say the when the mosquitoes are flying, they generate some sort of sound because of their wings, because they are flying very fast. Every mosquito having a different species are having a different frequency of flying at some different speed, and they all are different. So what we did is we collected all these different sounds of these mosquito species like Aedes aegypti, Anopheles, and Culex. We tried to classify these different wing beat sounds, and we were able to generate with a 79% of the accuracy for different audio of the mosquito wing beat sounds. And we actually deployed that onto a device. And finally, whenever there is a mosquito flying in the home, it will show you the name of that particular mosquito species, that you have an Aedes aegypti, or maybe you have a Anopheles, or maybe you have a Culex, etc. And if you integrate with a Google map and based on the locations of the sensor, instead of showing a traffic on the Google map, you can show that, okay, there are lots of mosquito breeding of Culex into say Motera area or maybe Maninagar area, etc. You can show a kind of a density of the mosquito species at different areas in Ahmedabad. So that is how you can create a mass impact for. But the fundamental concept was simply collecting the audio data and classifying them through Edge Impulse. There was no coding done. Directly, we uploaded all the data of various mosquito species. And finally, we did classification. We created a header file. We deployed onto a tiny machine learning. And finally, it was running well. And that was perfectly a project which was demonstratable. And for the similar way, again, there was a project done for kind of a baby cry identification. I think I posted a few days ago on the LinkedIn. So we collected various baby cries. Usually what happens when the baby is in infant stage, the communication is only the cry. If the baby is hungry, the baby will cry. If the baby is sleepy, it will cry. If the baby is, having some sort of discomfort, it will cry. But how a parent can identify? So if you consult a pediatrician, they will be able to tell you that because they have an experience, they know that what could be the reason and what is the different pattern of crying for the different babies. So we collected from YouTube videos of various baby cries, converted into an MP3 file, and again classify them using the same method of Edge Impulse. And I will show you that particular video which I recently demonstrated on my campus. If it works, then it is fine. So if you see this, right now it is recording. It is hungry. There is another video for discomfort as well as, sleepy also. So you can even find out, and it is the same board like Arduino Nano 33 having a 0.9 LED display and a battery inbuilt in that. And it will finally be able to identify various, audios. So it is simply an audio classification problem, but it is all about creativity. It is all about the way you try to classify the data. So I would recommend you that, use the same thing, but you can even try to use some creativity out of this one and you will be able to use it. Okay. Now going back to the slide. So this is the process of installing the libraries for TensorFlow also, because when you use Arduino Nano 33 BLE, you will have to install the TensorFlow library. It is by Google, but you need to install that for your Arduino ID and you will be able to good to go. And there are few examples ready-made available by the Arduino itself. So you go to the Arduino playground, you will be able to identify some source code which are able to capture the sensor data for accelerometer or maybe for audio, etc. You start capturing them through the serial port. These are the waveforms which I was showing you. Say, for example, if you're simply moving or maybe creating some gestures, you can record them. So in this example, I created only the left side movement of the sensor or maybe the Arduino board itself, captured the data for at least 10 times. Even having very small amount of data will be able to work very well because they have a quite difference in the sensor data collection, and that is why only 10 readings will also do. So give it a name like left.csv, right.csv, or maybe 1.csv, 2.csv, 3.csv, etc. And if you use this sensor and do fusion with some sort of magnetic field data with the earth, you can even create some sort of interesting projects out of that. So when you start recording the data from the serial monitor, you will be able to see that all the columns, comma separated values are basically for AX, AY, AZ, and you need only that. There is no need of GX, GY, GZ into this one. But if they are also with that, it will give you more accuracy or maybe a better outcome or the result of the gestures which you will try to test later on. And the problem with the serial monitor is that it doesn't allow you to, record all the readings all together. So whatever has been visible on the screen, you will be able to just select them and copy and paste it. So you need to do it again and again. It will take, so it's basically a time consuming process. Maybe you have recorded for 2-3 seconds. So maybe your serial monitor will scroll up number of data altogether, but it only allows you to copy which are available or visible on the screen. So you need to first capture this one, then go to the next part of the data and then copy. So it will take some time, put it into a text file initially, and then save that text file as .csv file. Then you will be able to open it into a Excel format. Or maybe you can use Google Colab also after that, how you can train the model. So that is how, if I can open this and if it is over there, I will show you how it works. These are all ready-made sample codes which are provided by the Arduino itself. So it is already there on the internet. You can just use them. All the data, the file which you have, you need to simply upload them onto your Google Drive, because whenever you are using Google Colab, it will not allow you to save your file of the data. It will save your code, but you need to again upload the file. So if you look at this file name punch.csv, so what I did, I recorded like this one, holding the sensor and punching something. I recorded those data. I call it as a punch.csv file name. But now the file is not here because it was done few years ago. So I need to upload that file again through this option. It gives you an option to upload the file from here and you will be able to upload that file. So whenever you close your Google Colab, it will actually remove the file which has been uploaded. So that is the only thing you need to keep in mind. I will share you all the codes and everything. If you are interested, you can even classify, you can create your own model and you can run them. But you need to have a kind of a board at least to deploy on hardware. And these are the examples of Arduino TensorFlow Lite tutorials, which you can refer as a beginner if you are just starting. So it gives you gesture to emoji. So maybe you are doing a gesture like this one. So it will show you a kind of a converting into an emoji of waving a hand. So maybe that is also possible by writing this one. So these are the examples provided here. Like fruits to emoji. If you identify a banana or an apple, it will show you an icon of those things. All these IPYNB file are available, so you can use that interactive Python notebooks. So I will share the slides, so you need not have to even record all this. Everything will be available, and you can even use these slides for your own projects as a beginner. Those who are already working must be knowing everything, but just for some of the audience, it would be useful. It takes time to load. So this is inside the Colab, which I was showing you. I have taken all the screenshots. So maybe sometimes if it is not running, I can show them. So once you will start install all the required libraries like NumPy, Matplotlib, and TensorFlow, it takes some time, like few seconds, because you are already running on the Google TPU. That is why it will not take much time. If you have like locally running installation of all these Python libraries, it's going to take too long time, and you will be getting lots of error also, and you need to install some dependency packages, etc. It's going to take too long time. I would recommend you to go and do everything on the Google Colab. So here how you can upload the data. Once you upload the data, these files will be visible here like flex.csv, punch.csv, and then this is the code by which you will be able to, I cannot explain everything right now in a just 1 hour of session, but you can refer this later on. So initially it will show you the recorded data which you had recorded for some sort of activities. So this is just reproducing what you have done so far. And finally, the steps is to train the neural network based on the CSV data. You can even randomize the split input and output pairs of training, build and train the model. Again, you can verify with the gestures again by doing that. And finally, what you will get is basically a file. You can name it as a model.h. Basically, it's an header file. So whenever we use Arduino boards, we include header files. But here, when you include the model.h, it is basically a tiny machine learning model. It is not a normal header file which you use for your Arduinos. So that is the model.h file. You need to add file, go to an option into the Arduino like tools and add files. And from there, you will be able to get the model.h from your computer, and it will show you like in a binary format, hexadecimal format. And once you run that model, like model is running on the board itself, now it will not show you the data because initially the program was written to capture the data, but now we have a ready-made model which is running. So whenever you move it, it will show you the accuracy like left. If you do it on left side, it will show you 99%. So maybe 0.99 shows you that it is the accuracy that you are having a correctly running model and it is having a perfect accuracy. But you need to do it for various different gestures, and even you can do it for a number of things altogether. If you don't want to record the data, I would recommend you to go to kaggle.com and even try to find out some available data set like human activity detection data sets. You will get lots of interesting data from that human activity data set. So these data have been collected through mobile phone or smartphones, and it gives you lots of various attributes which you can use them. So if I go to the file here. So instead of recording your data at your own, you can directly use the available data. Show you what are the different data available, train data. So it has 126 columns, sorry, 1126 columns. I just want to show you what are the different attributes in the data. So if you look at this, all the data are for various human gestures, and maybe there would be a label for that too at the end. When you have such big data, you need to use Google Colab for everything, and you can do classification. So if you look at any of the data science problem, say this is the activity. When the person was standing, this data was recorded. So all these are basically labeled as a standing data. These are the seating data, lying data, walking data, sleeping data, walking downstairs. Even you can find out whether the person is going upward in the stairs or downstairs. Standing, sitting again. So for various different users, that data have been collected. So then once you have this sort of data, you will be able to classify them. And if you look at the record, how many data, there were like 1100 columns. When you have such big data, you should use Google Colab, because normal computers either they require GPU or maybe it will take time. So even though you don't want to record the data through any such Arduino boards or accelerometer, you can use such data to do machine learning. And then once the model is created, so the beauty of tiny machine learning is all about when you have a huge amount of data. If you do normal machine learning for computers, it will give you a model of say 150 MB size. But when you do it for TensorFlow Lite for microcontrollers, it will give you just a 12 kilobytes of size. So all the data now converted into an intelligence, that is basically a small model, which will be able to run on any of the devices like ESP32, Arduino, Jetson Nano, whatever it is, it will be able to run on those devices. Going back to this. Okay. So this was about tiny machine learning or fundamentals of age computing, how we can do it. The only takeaway of this session is that whatever we do it for computers, it is all about huge amount of data or big data we use. Lots of data sets are available on the internet. But when you want to use it for embedded systems, or maybe any of the electronic chip, you want to make your own devices, maybe a CCTV camera. It is not a computer. CCTV camera also can also run the machine learning model inside that. It can also identify various objects automatically, because there is a tiny machine learning model running into the CCTV camera. So that is how you can do that. So the first part was all about using different boards. So I show you a kind of a TTGO, Liligo watch, which you can use ESP32. It has also a camera. There is a DF robot board, which you can also use for tiny machine learning. There is Arduino Nano. There is a VIO terminal with various sensors, which can also run machine learning models. So whenever you run it, all these on the such devices, that is basically the TinyML or edge computing, or sometimes physical computing. If you refer to the Harvard University course, in the master's program, they have a dedicated one course on TinyML itself. And the kit which I show you, that is by Dr. Janappa Reddy, who has actually designed that kit, and now it is available. Even you can apply as a faculty grant also to the Age Impulse Foundation, and you will be able to receive those kits. I think I have received it for 3 times. They normally send 10 different kits. Recently, I received this one, the Seed Studio kits. They are basically ESP32S3 having a camera module, Wi-Fi, antenna, and everything. And even that can also be used for TinyML projects. So now we have, I think, half an hour of time. So integrating generative AI is a completely different call. Usually what we do, we understand generative AI is all about kind of a chat GPT, but generative AI is completely different than whatever we are understanding. So I will show you some sort of LLM fundamentals, that how as a beginner you can start with working with the generative AI. This is a kind of an era where we do API calls most of the time. So we cannot build a OpenAI kind of an infrastructure. None of the company in the world, like only Microsoft, Google, OpenAI, or maybe Perplexity, are having their own infrastructures by which they are able to, the collect huge amount of data, run the model, train them, and finally providing all these intelligence. And they consume a lot of energy. They use a lot of data. They use a lot of bandwidth, power, everything in terms of storage devices, which normally a kind of a company or a government cannot afford because there is a huge investment of all of them. But if you want to make your own chat GPT, for example, or maybe your own OpenAI kind of a facility or server using a text file, maybe you have a book, say for example, a PDF file. If you want to create a kind of that sort of interface, it is necessary to understand the fundamental, how the journey started actually. So it all started with the NLP, natural language processing. So I will show you some slides quickly because we have only half an hour of time, but that will at least give you a kind of a glimpse of fundamentals of LLM and the story for generative AI. So basically, what is large language models? They are basically the neural network designed to understand, generate, and respond to human-like text. That is basically the large language model. Nowadays, people have started talking about small language models. So if you just research and search on internet, you will be able to find out something where now people are not, everybody cannot handle LLM infrastructure. And that is why people thought that let us have a small language model. Now, these days, we have SLM also into the market, and they are basically customized, application oriented, and based on the requirement, people use them. So whenever we understand anything about the generative AI or LLM fundamental, every time you will see that you are using ChatGPT, you are asking some questions. Everything is basically tokenization. So whenever we are like, sometimes, ChatGPT gives you a limit that now you cannot use ChatGPT because your limit is over. That is basically the token count. So whenever we give a sentence, we get the answer. ChatGPT servers basically count those tokens, and tokens are nothing but a kind of a word or a subword. So in this example, like NLP is written natural language processing. So natural language and processing are known as basically tokens. And these companies are basically charging you based on the how many tokens you are using. So maybe like 1 million token a month, or maybe 1,000 tokens per day, etc. Once you are utilizing those limits, you will not be able to utilize those facilities until and unless you are having a subscription with them. They will give you all the excess of using more and more tokens, and again they charge you. So whenever I show you that first example of DeepGram server and OpenAI and the 11 labs and everything, I have actually my account, and every time I send some sentence like asking what is the capital of India, it actually reduces those tokens from my account, and finally I will have to pay for that. So this is not a kind of a free me kind of a thing when we talk about generative AI and everything. It is all about making people habitual about using them, and later on you will not be able to live without that, and you will definitely pay with that. And you will be surprised to know that recently OpenAI announced for India that you will have a 390 rupees of license. That's a kind of a limited version of GPT-5 model. But on the day one itself, they generated a huge amount of revenue out of Indian users. And that is how, for 1 year, they allowed you to use it for free. And now just for 390 rupees, because you have been habituated, you are dependent on those tools, AI tools as an aid, and now you will be ready to pay those things. So NLP is all about starts with the tokenization, and token is basically a single word. Then we do stemming into the NLP. Stemming is something reducing the word to an original format. So if you take a word called running, to save the time, to save the memory, to save the processing capability, we transform them into its original format, and that is basically run. So if I'm say singing, so it will convert into sing. Similarly, all these words will be transformed by the method of stemming. Then comes the lemmatization. So lemmatization is all about reducing words to their base from using vocabulary and grammar rules. Say, for example, better you can transform into good. So maybe each and every time you don't need to look for different words, but maybe a kind of a similar words from vocabulary and finding out various rules for that. So that is basically lemmatization. Then stop words. Whenever we write a one page of Microsoft Word document, is and the etc. are of no use in the sentence. They don't show any meaning out of that. Even if you remove them, you will be able to understand. But these are basically the stop words, which we understand for our normal human to human communication. But when it comes to NLP, we need to remove them. And that is why is and the all are removed when we do pre-process the data for generative AI or maybe for normal NLP project. And that is why they are known as NLP. So these are some of the terminology which I'm showing you to understand some fundamentals of generative AI, but it starts with NLP. Then comes the bag of words. Say, for example, I have a sentence called I love NLP. So I is one, love is one, NLP is one. So how many times a particular word is in there? So it shows you a count of the word into a sentence. If you have a word which is constantly being repeated, and if you can recall the Sundar Pichai's statement last year at the Google I/O event, he talked a lot of about AI all the time. And somebody posted after that, on the Twitter that during this half an hour of maybe or 20 hour of the speech, 20 minutes of the speech, Sundar Pichai spoke AI 200 times. And if you have like seen this type of the this time his presentation, at the end of the session, he told that I spoke this word this many times because my Google Gemini system will let me identify the bag of words into my total conversation and everything. So it is all about finding out a particular word count in a sentence, how many times it is being repeated. Order is not important. Then comes the FIDF, maybe term frequency, inverse document frequency ratio. It is all about the frequency of a particular word or a term and the total amount of words into that particular sentence. It is divided by that. So it is a ratio basically. Then n-gram is all about how many n words from a text are there. So if you have a sentence called machine learning, it is basically n equal to 2. So that n-gram word is also popularly used in NLP. Then it comes the name entity recognition. Say, for example, if you have a sentence called Apple is in Cupertino, that's an headquarter of Apple. So here the name entity recognition is all about identifying what is the context of these words. Apple doesn't mean a fruit apple here. Cupertino is a kind of a location. So this is called an NER or maybe name entity recognition in NLP. Then it comes a word embedding where you can have a dense vector representation of words capturing semantic meanings. So king and queen have similar embedding in a model like word to vector. But when it comes to a different thing, say for example, if you're talking about a sleeping bed, maybe king size or queen size applies to the same bed. But when it comes to a person, king and queen are different. So the semantic meaning or contextual meaning is very important in generative AI. Normally, it doesn't understand in terms of what sentence you have written, but the order is also very much important sometimes. Say, for example, if I write that Ahmedabad won over Gandhinagar. So NLP will identify or maybe separate all these words. But now if you change the order, Gandhinagar won over Ahmedabad, the meaning will be different. So that is how the NLP understands the contextual meaning of the sentence and how it processes all these. And that is why it is so much intelligent in terms of human way it understands it. It replies you in a human-like contextual, meaningful answers, basically. Then the sentiment analysis, it will identify the text from the sentence and it will identify. So in this sentence, like love is positive. So basically it shows you a positive sentiment. I don't like the smell, for example. So don't is basically a negative sentiment. So it will identify the sentiments also from the text. Then cosine similarity, that it identifies, the contextual meaning of the different words. So a measure of similarity between two text vectors based on their angles. So you need to identify the cosine similarity also. So now you can imagine that a single line, how it is processed, like lemmatization, stemming, tokenization, cosine similarity, word embedding, NER, etc. Every process will be done on all the sentences. And it requires lots of power, memory, and processing power to consume all this big text. Whenever we upload a PDF document, it takes fraction of second for the generative AI from the OpenAI to process those things. So now you can imagine how the models are accurate, how the models have been trained so far. Then part of speech tagging is also very important in terms of assigning grammatical categories like noun, verb to words, etc. So maybe dogs bark. So dogs is noun, bark is a verb. And that is how it identifies the grammars also from the part of speech which you are providing to the OpenAI or any other generative AI models. Word frequency, that how many times a particular word appears in a paragraph or a sentence, etc. Parsing is all about separating the text, what we do normally in any of the programming language like string parsing or sentence or object identification through the words. Then it comes the word sense disambiguation, determining which meaning of a word is used in a context like bank, but it is not a normal financial bank, it is a river bank. So contextual meaning is very, very important. And that was the biggest hurdle. But a lot of interesting word to vector research has been done. And that is why nowadays it identifies the perfect meaning of a particular word in the sentence. Then perplexity. It is a metric for evaluating language models based on how well they predict a sample. Lower perplexity means a better language model. So it is basically a score. and there is a method to calculate the perplexity also. So perplexity is not that website. They have actually taken the name from NLP because they are also into generative AI, and they thought that let us keep a name called perplexity. So the meaning of perplexity is all about the performance of the model. Lower should be the better one. Okay, now I'm not going to cover all this because this is a very long one, but I will show you one important slide. Okay, just for information that we all talk about, chat GPT and everything, and we feel that it has all the data which has been used from the internet, but they have taken only a very small amount of data from the internet. They are not able to harness all the data. No one has that capability in the world to harness all the data available on the internet and to train, because there are no such hardware infrastructure available. No GPUs are available that can, process all these data, or maybe it will take tens of years to process and train that model, but that is not possible. So right now, GPT-3, when it was announced for the first time, they released that what data they use to train that GPT-3 model. So basically, it's a common crawl data. So if you look at this number, proportion in training data was 60%. So they are basically web crawl data from the internet. Number of tokens, 410 billion tokens, web text to web crawl data, some books, internet-based books, corpus, as well as some other books to corpus. So like 12 billion for the first corpus and second 55 billion for that. That only contains 8% of the data in the GPT-3 model. And Wikipedia articles, like they are high quality text. So 3 billion tokens from that. And that contains only 3% of the total training data. So now you can imagine that it is a lot of data which is still not covered by OpenAI or any other, like Google Gemini or maybe Meta's Llama model or any other models which has been used so far right now or popularly available. Nowadays, people are able to harness or capture only a small amount of data from the internet. And again, there are lots of ethical AI concepts in terms of copyright issues, that without any permission, you cannot download the book, you cannot use the text. So whatever has been freely available, these companies are able to use them to make generative AI models. So these are the GPT-3 data sources. All the links are provided. And they actually use the book 1 from the Gutenberg project, and books 2 is from Wikipedia Library Genesis. And if you want to start as a beginner to understand everything about, I would recommend you to read this paper. Attention is all attention is all you need. It was by Google, and you can see there is one Gujarati girl also, which was like, one of the first one to write about generative AI concept. When Google released this paper, they were not aware about that, it is going to create a very big impact. So actually OpenAI took this paper and they are heading in the world right now. Google was the originator or the innovator for the fundamentals of, GPT architecture. But because of, they couldn't use their own innovation, they couldn't use their own technology. So OpenAI took this paper and finally they started building the technology on that. And now Google is behind that OpenAI for at least for the generative AI concept, because the concept brought into the market for the first time was by this team of 7 people at the Google Research Lab, and they had an amazing one. And if you want to understand this paper, there is a YouTube channel, Papers with Code. So even it will tell you how this coding is done for this particular paper, how you can implement this paper, and even you can refer that. Okay. There are lots of different technologies of the attention. I think I would keep it up to this much, because now it is of no use of explaining all these in, because they are very advanced version of the generative AI models. Okay, I think we are a little bit early to finish. So what we do, we will have some Q&A for 10 minutes and then we will finish. Janvi, are you there? If you can take the question and answer. I mentioned the papers with code.
So, yes, sir. Hello.
Papers with
Yes,
code.
sir.
Yes, yes, I can hear you.
Any question answer from participants?
Code.
Karuchu.
See, this is the channel I was talking about.
Participants can unmute your mic and ask the question to the sir.
So this is the papers with code website where you can get all the papers. You can even go get all the codes on the GitHub repository or archive page and everything. So you just search the paper. Most of the codes are available. Usually they are not released by the researchers, but there is a repository which people maintain and write the code over there. Even there is
Hello,
a
sir.
repository. Yes, please.
Yes. Sir, what are the main risks associated with deploying LLMs in critical domains?
It is all about, first of all, open source models which you can access like Llama and all of them. And the biggest thing is that most of the model, see, right now, I don't find any problem in terms of using them or maybe any critical scenarios where you find a problem in using them, because all the models have been trained in terms of keeping in mind the ethical aspects of using them. If you try to ask any of the weird question to these models, or maybe you ask ChatGPT to create an image of some weird personality, it will not give you any answer. So it means that everything is built in the model itself. So there is no harm in using them, and nobody will be able to even play in that way in terms of negative sense. Or maybe like, say, if you ask about that generate a video of president dancing or something like that, or maybe create a image of a person like this or that, you won't be able to do that because the models are trained like that only. And that is why whenever we are using an open source model, I don't see any harm in using them, because there would not be a problem, because everything is in the intelligence of that model, and there would not be a problem. Yes, any other question?
Hello,
It
sir.
would be better. Yes, please.
Sir, what
Uh,
future improvements are expected in LLM research, sir? What are the
Future
future
improvement is all about, the biggest problem is all about handling lots of tokens and the pricing and the energy being, or maybe the resources being utilized. So nowadays, what people are trying to do is that, dividing such big LLMs into providing various services. Say, for example, if I'm interested in X area, then they have a kind of clusters of this sort of intelligence, that these queries will go to that particular part of the model only, or maybe that query will go to that part only. Say, for example, I'm asking scientific questions, then that will take care of that questions only. And that is how it has been subdivided. The biggest problem right now is that not a single organization individually can set up all these big things to run such big models, to train such big amount of data, and to provide the services, because there are like billions, trillions of queries are being handled by all these big servers. So right now, the biggest problem is that how we can reduce this consumption of the power, how we can reduce the GPU utilization and everything. But this is basically an AI race. Everybody wants to be ahead. And nowadays, they are only interested in investing lots of money, that we want to be the first in the world. We want to control everything in the world using AI. And that is why there is a race among all these 3, 4 big companies. And even the countries are also competing right now, that India is building its own AI infrastructure in terms of large language models. United States has already big companies having all these models and everything. So it is all about, it's a race right now. Nobody is earning. Even OpenAI is not profitable these days, having even this sort of biggest innovation in the world right now, a kind of a revolution, I should say, but still they are not profitable.
sir?
Yes.
Hello?
Yes,
Sir, why
please.
Hello,
are
sir.
LLMs considered as black box models, sir?
I don't know why they are called black box model. Basically, they are already trained. It is in terms of, say, let us take an example of a gesture recognition model, which we are talking about today, like we have number of sensor data for different gestures, we created a model. So we got a model.h file. Now, if you open that model.h file, you are not going to get any information from that because that is basically the intelligence what you have. So it is something like a black box. You don't know anything what is inside that because now once it is trained, or maybe you download a Llama model from Meta's website and you use it for your own applications, but you don't know what is there inside because the way it has been trained, the data for which it has been trained, what are the different sort of accuracies for various different sort of data for which it has been trained, you will never be able to get anything. And that is why there is a concept of explainable AI. These days there is one community who is constantly talking about explainable AI, that say I have an Amazon Alexa at my home, but I don't know what happens to my audio, even how the model has been trained on which kind of a data. So now it is the responsibility of the company who is making any of the model, whether it could be a generative AI model or a normal AI model. They need to tell the user that, okay, your data is going to be utilized in this way, or maybe the model which is running in the device which is at your home, it has this sort of functionality of working, the steps in which the model works, how the data for which it has been trained. You should also be able to know that on which different voices it has been trained so far, whether the data contains for all sort of genders or maybe all sort of age groups, maybe people having some sort of speaking problem, or maybe disabilities, or maybe that has been trained for those users also. People should be able to know that. Say for example, I have a speaking problem, I'm like some sort of I don't know the word, what should I call it, but I cannot speak very well in terms of any of the word. I take some time to pronounce that word. So if I buy an Amazon Alexa and if it is not going to work with my audio, then I should be able to know about, and that is why we call it as an explainable AI. There are lots of research groups working that are promoting, and these days companies are also telling you that how our models are running basically. But these days are also right. There is again a truth is that we don't know what is happening inside the model, and that is why we call it as a LLMs are like black box.
Hello, sir.
Sir, this is a repeated question, sir. You have explained earlier. Sir, may I ask you again, what are some real world applications of generative LLM?
You can search on internet, ask ChatGPT, you will get lots of answers. It is up to you how you want to use it. You just give me an area, I will be able to show you that how you can use it, generative AI. So if you have any idea in your mind, you just tell me how to use. I will give you the answer for that.
Sir, if we want to do the optical character recognition from the video, then is it possible with the ESP32 cam board or?
Yes, you can do that. You can do that.
So, sir,
It is
can you
possible.
suggest which model is helpful for?
See, initially you can start with YOLO, and there are lots of examples available for ESP32. So you can start with that, and then you can replace with your model. Or maybe I would suggest you to use Google Inception model. So Google Inception has been trained for, number of objects altogether. You need to simply fine tune the last layer of that Inception model with your data. So the example which I was explaining during my session, that, how can we identify the student's result from their face? So I use the Google Inception model for that, and I trained with those 20 students of pictures of various angles, through various angles, their facial pictures, and that was trained. But the model was Google Inception model. It was like already trained for number of objects in the world. Almost none of the object has been left out. But when we do retrain for our data, finally it will work for our own data only. So maybe you want to do optical character recognition, you'll be able to use it because the quality of the camera is also good. It's almost a 3 megapixel of camera which you get with this board. So I don't think so there would be a problem with that. Even like people are using it for microscopes also to classify, various things on the slides and everything. So they take pictures through ESP32's camera from the Microsoft itself, create a data set, and then do the classification with various Inception model or maybe YOLO or any other models.
Okay, sir. Thank you.
Okay, any question from participants?
Okay.
Okay.
So thank you for joining and listening. Though I would I had some sort of, jumping from one slide to demonstration and all different things all together. But my intention was just to make you aware about what you can do with all these, like maybe the TinyML or maybe generative AI or various boards available, because most of the faculty members or the participants would be from electronics and communication or computer science background. So it comes to, utilizing them. You just buy it and start working on them within half an hour or a day. Maybe you will be able to make everything in terms of working. That is how you will be able to do it.
Okay. On behalf of sir, every participant, I extend my heartfelt thanks to Dr. Kiran Trivedi sir. Sir, the way you connected cutting edge research with real world use case made the topic both engaging and relevant. We truly appreciate the time, energy, and the passion you shared with us today. Thank you once again, Dr. Kiran Trivedi sir, for enlightening us with your knowledge and leaving us with new ideas to carry forward, sir. Thank you, sir, once again, sir.
Thank you so much and good night to all of you. Thanks a lot. Should I leave now?
Okay, sir. Thank you, sir.
Bye.
Thank you, sir. Thank you very
All
much.
participants are requested to turn on their camera for group photo. All participants are requested to turn on their camera for group photo. कैप्चर नहीं कर सकते All participants are requested to turn on their camera. नहीं शुरू से भी करो हाँ तो पहले वीडियो Okay, you can turn off the camera. We took the photographs. Thank you. You may leave now. Sir, attendance ले लीजिए. Recording stop करी sir.